Amazon Web Services has a lot of pieces to it, and it can be hard to figure out just where to get started. For instance, if you look at the reference architecture for hosting WordPress, you'll see clouds and tons of colored squares and some funky looking orange pole that's got orange sticks poking out of it. It's madness. In reality, there's several different ways to run an application, like WordPress, from within Amazon Web Services, and not every application will need to go with an architecture that's this extreme. When you're first starting out with AWS, think of your AWS account like a starship. It could be lean and fast like the Millennium Falcon, and it only uses a few AWS services and can easily be run by 1 to 2 people. Or your AWS account might be like the Starship Enterprise, with many different decks and hundreds of rooms tying together a multitude of AWS services while being commanded by several engineering, science, and security teams. My name is JV, and I've been coding on web applications and running servers for over 20 years now. And when I started using AWS several years ago, I was just as overwhelmed as you might feel now. But don't worry. I'm going to walk you through everything I wish I had known back when I started. So hop on board while we explore the different decks and rooms of our AWS Starship and learn the basics of how to keep our Starship running at light speed. Engage! Amazon Web Services has over 100 different services, and it just seems like they're adding more and more each year. Now, don't worry. You're not going to be an expert in every service. I'm not an expert in every service. I mean, they've got AWS Ground Station for helping you communicate with your fleet of satellites in orbit. I don't have satellites in orbit, but if I ever run into a situation where I need to download data from satellites, I know that AWS has a service for that, and at that time, I'll just read the documentation and start looking for some other courses in our catalog that can give me some more information on how Ground Station works. This is how you'll walk around your AWS Starship as well. Once you've identified a potential need for an AWS service that you haven't used yet, you'll walk into that unused room of your Starship, turn on the lights and start twirling knobs and dials, and then explore a catalog for a course that's going to take you deeper into how to actually use that service when developing for your application. So it's important that you start learning what kinds of services AWS offers, what AWS has named that service, and the architecture icon for that service that you'll find in the documentation, blogs, and in other courses. Okay, fine. So why are we even doing this? As an example, let's say that your mobile application has a feature that lets your users upload video taken from a job site. You could install some open source tools directly onto some AWS servers and build a background job that processes these videos into different sizes and formats. Or you could have just used the Elastic Transcoder service, which is cheaper, more scalable, easier to use, and saved yourself a ton of time and money. You just need to know that Elastic Transcoder processes videos, and when you have a potential need for it, look up its pricing, figure out how it works, which might include reading a few architecture diagrams, and then determine if it's right for your project. Once again, you aren't going to use every service that AWS offers, but you should know what all the services can do for you so that when you're building your app, you can use the right tool for the right job. Oh, and to make things a little more interesting for you, AWS has published new versions of the architecture icons, as you'll see in these clips from the AWS This Is My Architecture video series. So sometimes you're going to see diagrams that use the new icons, and then sometimes you'll see diagrams that use the old icons. For this course, we'll use the new icons, and these are usually labeled on the diagram, so don't think you need to memorize the service name for all of them. However, when I show you the old and the new icon at the same time, these are common services that aren't typically labeled on the diagram, so these are the only instances where I suggest you learn both icons, the name of the service, so this is Route 53 as an example, and a brief summary of what this service does. Route 53 is for DNS records, and I'll get into all that in a later video. But before we start diving into a bunch of AWS services, we're going to cover some key security concepts that you're going to see come up again and again in the various AWS services. And we're going to show you how to safely use your AWS Starship for the first time so you don't, crash it into the side of a planet. Then, we're going to start from the bottom of the Starship in our engine room, and we're going to get our hands dirty with some servers and some storage options and go through some cloud networking concepts. From there, we're going to move up to the nicer decks of our Starship, where AWS has done all the work of managing servers and databases, and look at the various tools they have for quickly deploying your code, or helping you quickly develop a mobile application, or leverage machine learning in your application for text recognition or voice detection. Along the way, we'll encounter several terms that you might have heard related to cloud computing, such as infrastructure as a service, big data, and serverless architecture. Hey, listen, don't worry. We're going to break down all the buzzwords for you, so get ready to learn. You don't have to be an expert on managing servers to take this course, but it helps if you have a basic understanding of how a computer works and how devices talk to each other in an IP network, much like the network you probably have at home. This course is going to introduce cloud computing concepts using computer parts that you would find on the shelves of any big box electronics store, such as CPUs and RAM and networking switches and routers. So it helps if you've used these components before and you're at least a little familiar with what they do. The application that you're developing may not be a web or mobile app, but I'll introduce you to some cloud concepts by showing you a few ways you can host a website with AWS, such as one built on WordPress. You should have a basic understanding of how a web server works and how a domain name like linkedin.com points to an IP address for serving up that site to your web browser. You likely don't transport your source code around using a huge external hard drive like this one anymore, but this hard drive will represent the source code and the assets to the application you want to run from within AWS. And this book will represent the database to your application. This is all of your user data, transaction history, website analytics, pet medical records, whatever. You should be familiar with what a database does and how you would use it in your application to read and store user data. We'll also look at a few code samples, but we'll keep the samples as simple as possible. If you have any familiarity with a modern programming language, you shouldn't have too much trouble reading the code samples, even if it's in a language that you haven't used before. Let's get started. Before we do anything on your AWS account, we first need to figure out what kind of account you have. If you don't have an AWS account, you can sign up for your own account by going to aws.amazon.com. You'll be asked to put in a credit card on file for the billing, but most AWS services have a free tier that allow you to try out several services for the first year while you're learning about AWS. If you signed up for your account this way, or someone in your organization only sent you a username and password, then you have an AWS root account. If you were sent a username, a password, and an account ID, or an account alias, or maybe someone sent you a special link to click on to sign in, then you have an IAM user account. IAM stands for Identity and Access Management, and this is how AWS controls who has access to your organization's account. Now, if you have an IAM user account, then your login screen will include a field at the top that says account ID or alias, and it should already be filled in for you. If you have an AWS root account, you are using a special account within AWS, and you should only sign in to AWS using the root account under certain circumstances. When you sign in with the AWS root account, you become captain of your Starship. And the captain of the Starship has special abilities. You can promote and demote your officers. You can even tell your ship to self-destruct. When you interact with AWS using the root account, imagine yourself wearing the captain's uniform and the great responsibilities that come with the uniform. There's a complete list of the special privileges the root user has in the documentation, but the most common uses are creating your first IAM user, changing the login credentials of the root user itself, changing your support plan with AWS, and deleting the entire AWS account. So you can see how dangerous it would be for someone to get a hold of your AWS root account. You never want to give out your AWS root account, and you should only log into the AWS root account when you absolutely have to. Make sure your AWS root account has a strong password. And if you want to take extra precautions, AWS recommends that you secure the root account by using a physical multi-factor authentication key. The MFA key requires that whoever puts on the captain's uniform must have the root username and password and have the MFA key in hand. The physical MFA keys they support, along with their associated costs, are listed in the AWS docs. To set up MFA, log into the AWS console, click on your username in the upper right toolbar, and in the submenu select My Security Credentials. Under Multi-Factor Authentication, click on the Assign MFA Device button. The Virtual MFA Device option allows you to use an app on your phone in place of a physical device, but I recommend using the physical MFA key for the AWS root account and then using the virtual MFA option to secure your individual IAM user account. To set up MFA, you just follow the instructions listed in this wizard for the device that you selected. Now, let's keep on the captain's uniform just a little bit longer so we can create you an IAM user, and then hang up the captain's uniform up in the closet where no one can find it. As the root user, click on your name in the upper right side of the AWS console, and then in the pull-down, click on My Account. If you were given an IAM user to log into AWS, you can still follow along with these steps, but since you already have an IAM user, you won't need to create a second one. You also may not see all of the same options since you aren't the root user. Scroll down until you see the section titled IAM User and Role Access to Billing Information. Click the Edit button next to the User and Role Access to Billing Information, and click the Activate IAM Access checkbox, and then click Update. This will allow an IAM user, such as yourself in a few minutes, to control access to the billing areas of AWS so that someone other than the root user can see the current charges that are being racked up or change the billing details. Scroll up to the top and click on Services, and then in the Services search, type IAM and click on the entry that auto-completes. In the IAM console, on the left, click on Groups. Now, I recommend dividing your team up into groups because when you add a new IAM user to your organization, you can simply add them to the appropriate group and they'll inherit all the permissions that you've assigned to that group. And since this may be something you're only doing occasionally, it's easier to assign new people to an existing group than it is to remember all of the permissions that they're going to need each time. Click on the Create New Group button, and for group name, type Admins, and then click Next Step. Click the checkbox next to the Administrator Access Policy. Now, this list includes all the default security policies that AWS has, and you can also create your own custom policies in another area of IAM. If you would really like to dial in exactly what your team members have access to in AWS, search our catalog for IAM policies and you'll find several courses that show you examples of how to write and test custom policies. AWS recommends that you follow the rule of only granting least privilege, or only giving your team members the bare minimum of rights over your AWS account that they need to perform their jobs well. After you've attached the policy, click the Next Step button. Notice next to the Policies label that the Administrator Access Policy has an ARN, or ARN, and this stands for Amazon Resource Names. All of your cloud infrastructure, including your servers, networking components, storage, IAM users, your roles, almost everything will have a unique ARN. This is like the dog tags to your cloud infrastructure. Everything will have a unique ID, and you'll use these IDs in various places around AWS to link your cloud infrastructure together. It's like a primary key column in a relational database. Click the Create Group button. Now, click on the group name Admins, and you'll see the ARN that was assigned to this group. That number that you see listed in the ARN is your account ID, and everything billed under this AWS account will be tagged with that number, so you'll see it a lot. On the left-hand submenu, click on Users. And at the top, click the Add User button. For username, type a username for yourself. And under Access Type, select the checkbox next to AWS Management Console Access. This will grant our IAM user we are creating for ourselves access to the AWS console, but we're going to leave programmatic access off for now, and we're going to create our access keys in a later video. Click the Next Permissions button. Click the checkbox next to the Admins group to add this user to the Admins group, and then click Next Tags. Click Next again, and then click the Create User button. You can click the Show button next to the password and copy this temporary password into a text file, but don't save it yet. Copy the login URL listed above your login details. Click the Close button at the bottom of the screen, and now log out of the root user by clicking on your name at the top, and then in the submenu clicking on Sign Out. Now go to the URL that you just copied. You'll see that it auto-fills your account ID. So now type in your new username, and then paste in the temporary password. Sign in to your new IAM user. Set your new password and click the Confirm Password Change. There you go. Now you can put away that captain's uniform and only start using AWS with your new IAM user. Now, from here, you can go back into IAM and create new users for the rest of the people on your team. If you need to organize a large team and maybe split up your account into separate departments with a complex hierarchy of permissions, watch the AWS Online Tech Talk on scaling account and permissions management. Let's now explore what the access keys are and how to create them. Click on your username in the upper right toolbar, and in the submenu, select My Security Credentials. Under Access Keys for CLI, SDK, and API access, click on the Create Access Key button. Click on the Show Secret Access Key link. Copy both the access key ID and the secret access key into a secure password store, such as LastPass, 1Password, or a similar tool. Now, take note here. You will only be shown the secret access key this one time, and there's no way to go back later and retrieve it again. So if you don't record this into a secure place for later use, you can't come back in here and look at it again. You'll have to delete this key and then create a new one. We need this key because later in the course, we are going to use the AWS Command Line Interface, or CLI, to interact with our AWS account. And you'll need this key to tell AWS who you are and for when you're developing locally. AWS even has their own Git hosting repository service that's a little more basic than GitHub, and it's called Code Commit. But whether you're using GitHub or Code Commit, if you check your access keys into your source code and you have a public repository, everyone on the internet has your access keys. Even if your repository is private, your keys will still end up on every developer's machine who clones your repository. Now, someone can't log into the AWS console with the access key, but they can use the API through the AWS software development kits to do almost anything that you can do in the console and do a lot of damage to your AWS account. After you've created your access key, click on the Close button. Now, if your access key is ever leaked out, you're going to need to come back in here and delete it immediately, and then generate a new one. You'll also find these exact same settings in your AWS root account. So AWS will let you generate an access key for your root account. Unless you have a very specific reason for your AWS root account to have an access key, never ever create an access key for your root account. You will also see the Assign MFA Device button below the access keys. And again, I highly recommend setting up multi-factor authentication for your IAM user to help secure access to your AWS console. However, MFA won't do anything to secure your access keys if those get out into the wild. Man, nobody likes paying bills. AWS has made this a little easier on you by asking for a credit card up front when you create your AWS root account. The only problem is they'll charge your card automatically each month based on your usage and then send you the statement after they've already charged your card. And so if you're not watching your usage, then you're going to be in for quite a shock. But don't worry. There's some alarms that we can set on your account so that you don't run into any surprises. From within the AWS console, click on the upper left menu, click on Services, and type Billing into the search bar, and click on the entry that auto-completes. Underneath Preferences on the left-hand side, click on Billing Preferences. Click on the Receive PDF Invoice by Email checkbox to get a detailed breakdown of your charges emailed to you each month. Click on Receive Free Tier Usage Alerts and type in your email address. Several AWS services have a free tier offering that allow you to try out the services for free in some limited fashion. And if your AWS account is less than a year old, you'll get some additional free tier offerings. If you want to keep everything within the free tier, check out this page for the service that you're wanting to demo and see what the restrictions are. AWS also has a pricing calculator that you can use to see if the service has a free tier, and if not, how much would you be charged to use the service if you only used it for 1 month? Although, even this is usually a worst case estimate because you may only use a service for a day or two just to see what it does. If you're experimenting with AWS, make sure to keep a list of all the resources that you create so that you can go back and delete them later and stop the billing. Back in the billing console, make sure the Receive Billing Alerts checkbox is also checked. You have to turn this setting on for the first time to tell AWS that you're now going to create some billing alarms based on estimated usage. Click the Save Preferences button. Then, on this same screen, underneath the description of the Receive Billing Alerts options, you'll see a link that says Manage Billing Alerts. Click on that and it's going to launch in a new tab. This is the CloudWatch console. CloudWatch is an AWS service that allows you to look at charts and graphs of your cloud infrastructure and to set up monitoring. You can use CloudWatch to monitor the health of your servers, view detailed logs, and set up billing alerts. On the left-hand submenu, click on Alarms and click on the Create Alarm button. Click on the Select Metric button, and in the bottom of the window, click on the Billing card. Then, click on Total Estimated Charge, and then click the checkbox next to the US dollar currency, and then click the Select Metric button. At the bottom of this screen, under Conditions, put 50 in the Then box. So now, this alarm in CloudWatch will go into an alarm state whenever our estimated monthly charges are greater than $50. Click the Next button. Under Select an SNS topic, click on Create New Topic. For topic name, type Estimated Monthly Charge Exceeded with no spaces. And then, under the email endpoints that'll receive the notification box, type in your email address. When you are finished, click the Create Topic button. SNS stands for Simple Notification Service, and it's a messaging service that's used by CloudWatch, but you can also use it in your own application for sending emails and text messages and push notifications. We'll talk about SNS later. At the bottom of this screen, click on the Next button. For the CloudWatch alarm name, type Estimated Monthly Charge Exceeded with no spaces and click Next. And at the bottom of this summary page, click on the Create Alarm button. You'll need to check your email and click the opt-in link to the SNS topic that we just created. After a few moments, click on the Refresh button and you'll see the state change to OK. When your estimated charges go above your set threshold, you'll get an email now letting you know that this alarm has gone into an alarm state. Okay, so CloudWatch can be a little overwhelming, but you're doing great. Let's pull way back and look at how AWS started before we create some servers of our own. Let's clear the air and demystify the cloud. And to do this, we need to go back in time to the birth of the cloud, to the year 2006, right before Amazon Web Services launched. So at this time, to host an application over the internet, most medium to large organizations would self-host and build out an expensive data center room in their office, or they would do what most small businesses were doing, and they would rent space in someone else's data center, called co-location, which would provide you with redundant sources of power and internet so that, your whole website doesn't go down every time building maintenance shuts off the breakers. If you've never been inside a data center, you've likely seen one of these in the movies. This is the part where the hacker breaks into the super secret facility, plugs their laptop into one of the racks, and steals the secret files. And a real data center really kind of looks like that, except that person in the hoodie crouched on the floor with their laptop is someone who actually works for the data center and not a real-life hacker. All right, so what we're looking at here is just one of those servers from one of those racks. Now, I've taken the lid off the server, and now we can see inside it, and if you look at it, you'll see that it's mostly all the same components you would find in your computer at home. These components are just ranged in a different casing so that it slots easily into the rack to save space in a data center. But it's still got a processor, it's got sticks of RAM, and it's got a hard drive that's 99% identical to the one that's in your computer at home. So let me push this off to the side. Let's take a look at this. This tower computer is sold as a small business server, and it has almost the same components as the flat 1U server in the rack. It just comes in a different form factor. In fact, it's almost identical to a tower computer you'd use as a workstation or your PC at home, except usually these servers don't have these sweet graphics cards because they rarely even have monitors attached to them. We'll use this small business server in this course when referring to servers, although in real life, your cloud servers run off a flat 1U server like the one that we saw earlier. So in 2006, if you needed a server, you would just go online and buy a server, just like you would shop online for a new laptop, and you just have this giant thing shipped to you. Then you would self-host it from a room within your office, or you'd set it up. The fancy word for this was to provision it, and then take it down to your co-located data center, which was called the colo, and slot it into your server rack. So a third option that you had is that you could lease dedicated servers. So instead of bringing your own server down to the colo, you would just rent one of these servers. And if anything happened to, say, the hardware of the server, instead of you driving down to the data center to fix it, the data center techs would just walk over and look at your server and fix anything that was wrong with it. These three types of deployments fell under a category called on-premise hosting, which is some form of just do-it-yourself hosting, where you had the full responsibility of figuring out what to do if your single server failed on a busy Tuesday afternoon. So around this time, virtualization started to appear within the server space. Now, a virtual server is just a software abstraction that allows a physical server like this to divide up its CPU and its RAM and its disk resources, which is called the bare metal, and run different virtual servers on top of the bare metal. And they may even have different operating systems from the physical server's operating system. So this allowed a single physical server to split up its resources and appear to the outside world as 3 or even 10 separate servers. So you can do this today with your own computer using software from VMware or VirtualBox, and it'll let you run an old copy of, say, Windows 7 virtually on top of any operating system you've got. Why does virtualization matter? Virtualization let data centers sell even more dedicated servers, because now I can get maybe 4 virtual servers out of 1 physical server. Let's talk about how Amazon started capitalizing on this technology to fix some of the common problems that people were having with dedicated hardware. Running your own servers, whether from your own office or from within a data center, has a lot of challenges to it. You need to have staff that understands how to maintain and to fix all that hardware. And that team also needs to be responsible for maintaining all the software that's running on that hardware. Another issue that companies were facing was scaling. So depending on how your application works, a single server has a limit to how much traffic it can handle. Doubling the size of your business might mean that you have to double your physical hardware to handle the load. But what if, over the weekend, your website suddenly got 100 times the normal amount of traffic because you got mentioned in a news publication? Typically, the servers would become so overloaded that most people trying to hit your website would wait and wait and wait, and they would see nothing. It could take weeks to order and set up new servers, so by the time you racked 10 more servers and brought them online, the traffic from that news article has already moved on, and you lost a key moment to acquire a lot of new customers. So to help with this, Amazon launched 2 services. One of these services is called Elastic Compute Cloud, which is abbreviated as EC2. This is the old icon for the entire EC2 service, and this is the new icon. On the surface, this just looked like virtual servers that you could rent from Amazon, which a lot of other companies were doing this at the same time. The secret sauce here is that word elastic. Think about the number of servers stretching automatically when traffic increases and then shrinking back down again when the traffic drops off. For EC2 instances, this feature was called Autoscaling. So when all that traffic hits your website over the weekend, EC2 would autoscale your existing server from 2, maybe even up to 10 to handle the load, and then back on Monday, it just scales back down to a single server when the traffic is gone. The other AWS service that got launched in 2006 was called Simple Storage Service, and it's abbreviated as S3. Here's the old icons for S3, and this is the new one. S3 was Dropbox before there was Dropbox. It was a simple way to access off-premise storage for your important backups, like hard drives in the cloud. And Amazon used their size to offer this monthly service at a pretty cheap rate. In fact, when Dropbox launched 2 years later in 2008, it was originally built on top of S3 and EC2. So when you were using Dropbox, you were really using S3 storage. Because you could now virtually build servers and storage solutions in the cloud with EC2 and S3, these services acquired the term Infrastructure as a Service, or IaaS, where instead of building out your own physical infrastructure of racks and servers, you're renting someone else's racks and only paying them for how much of the service you consume. The cloud revolution led to greater uptimes and total lower costs of ownership because you no longer had to buy your own physical servers and replace them every few years, and have all that staff to maintain that hardware. However, even though Amazon manages the physical servers, you still have responsibilities over the software on your virtual servers. This is called the shared responsibility model, where you and Amazon Web Services share different responsibilities in keeping your servers up. AWS handles the data center and its physical security, so no one can sneak into the data center and steal your files. And AWS holds certifications for the physical and hardware requirements of most industry compliance standards. They will also handle hardware level problems with all those servers sitting in their racks. To use the infrastructure as a service offerings, you are responsible for the security of your virtual machine. You will need to run the operating system updates for Windows and Linux, configure backups, make sure your firewalls are set up correctly, and check on these things regularly on a maintenance schedule to ensure that you're practicing proper security. You are also responsible for ensuring that your application is secured against known attacks, such as SQL injections. Okay, if these topics are brand new to you and you've never managed servers before, search our catalog for Windows Server Security or Linux Security, and you can dive deeper into these topics. To get started with application security, check out our course on learning the OWASP Top 10, which will cover the top 10 vulnerabilities in web applications. Each AWS data center has its own set of electricity and internet providers to ensure redundancy if one provider is having an outage. Amazon has built multiple data centers near each other, and it's linked them all together with fast connections. Amazon has grouped these data centers into availability zones. You won't ever see which exact data center your AWS services are running in, and AWS keeps the data center's locations as secret as they can, but you do select an availability zone, so your services may be served up behind the scenes by one or more AWS data centers linked together within that availability zone. AWS recommends that you always design your cloud infrastructure so that it can run simultaneously across at least 2 availability zones. Going back to our server rack, they want you to think of a single availability zone as a single rack in the data center. So if you want your service to have the highest uptime, you need to be able to accept the loss of a single availability zone. You'll see options within various AWS services that refer to multi-AZ for cloning your service into at least 2 availability zones. Okay, let's zoom out once more. The availability zones are clustered together by region. So all of the availability zones near North Virginia are called the North Virginia region, or US East 1. And the availability zones within North Virginia are labeled as US East 1A, US East 1B, and so on. Since each availability zone has so many redundancies, and if you go with a multi-AZ architecture and run your services across at least 2 availability zones within a region, you are protecting yourself fairly well by running everything out of a single region. We'll set up 2 servers within the same region, but in different availability zones. If your application needs to be built to withstand the failure of an entire region, check out my other course on ECS and multi-region load balancing, and search our catalog for AWS High Availability for some other courses on how to design applications for the highest uptime. To switch which region you are in and to create cloud infrastructure within a given region, click on the region pull-down next to your name in the upper right-hand corner of the AWS console and pick a region you'd like to use. For my demo, I'm going to create my infrastructure in US East 1, which is North Virginia. When selecting a region, pick a region that is closest to most of your users and supports the AWS services that you want to use, because not all regions offer the exact same services. The largest regions are North Virginia, Ohio, and Oregon, and they usually get new features before the other regions, so these are always a safe bet. When any of these regions does have a large outage, you'll usually hear about it later on in the evening news. When you create a new EC2 server, you're ordering a virtual server with the specifications you select that's delivered directly to your AWS account with 1-minute shipping. Soon, Amazon will have figured out how to get me a roll of toilet paper that fast. From within the AWS console, click on the Services pull-down and type EC2 into the Services search bar and click on the entry that auto-completes. click the Launch Instance button. Virtual machine images in AWS are called AMIs, or Amazon Machine Images. On this screen, you can select from any number of AMI images that Amazon has already created. So you can start with a blank server that includes Linux or Windows Server, and it's already set up for you. Select the Ubuntu Server 1804 image and click Select. On the Instance Type screen, you'll select what kind of hardware you want allocated to your virtual machine. We'll get more into the instance types in the next video, so for now, select T2 Micro. Click on the Review and Launch button, and this will skip us straight to the final step of the wizard with all of the defaults selected. If AWS won't let you click on the Review and Launch button, you may need to recreate your default VPC, so check the AWS docs for steps on how to do this. Click the Launch button. To connect to the instance, either through SSH on the terminal for Linux instances, such as this one, or Remote Desktop Protocol, or RDP, for your Windows Server instances, you'll need to create a key pair, which will become the password for accessing this instance. In the first pull-down, select Create New Key Pair. And for key pair name, type AWS Demo, and click the Download Key Pair button. Now, click the Launch Instances button. Then, click the View Instances button. And you can see now it's starting our EC2 instance. On the name column on your EC2 instance, if you hover over it, you'll see a little pencil, and you can click on it to edit the name. Type Web Server 1 and click the check mark. When your instance goes into a running state, make sure it's selected, and then click the Connect button. This modal will give you some instructions on how to connect to your running instance. Now, if you're using Windows on your PC, you can click the Connect Using PuTTY link to view instructions on how to connect to this Linux instance using PuTTY. For macOS, open a terminal window. The .pym file I downloaded should be in my local users downloads folder, unless you customize this setting in your browser. So type cd for change directory space ~downloads and hit enter. Type ls to list all the files, and there's my AWS demo.pym file. If you want to see what's inside here, type cat space AWS demo.pym and hit enter, and you'll see an encoded private key. Now, the associated public key is already installed on your instance for you. Now, keep in mind, this AWS demo.pym file is the only copy there is. You can't get it from AWS later if you lose the file. If you have a team, you'll need to share this file with them securely so they can connect to your instances. I usually take the contents of this file and I paste it into my team's encrypted password store, such as LastPass or 1Password, and only share it with the people who need it. If you lose your key pair, there's no way to recover it, but you can go through a pretty complicated procedure that's listed in the AWS docs to create a new key pair and install that new public key on an image of your affected instance and then relaunch it. But to avoid all this, just don't lose the key pair. I usually move the .pym file into my user's hidden.ssh folder because that's where my other keys are for GitHub and my other servers, but this step is optional if you don't have a .ssh folder yet. So type mv for move space ~downloads /AWS demo.pym space, and now I'm going to move it into ~.ssh and hit enter. And then, following the instructions on the EC2 console, I need to set the permissions on my AWS demo.pym file. So in my terminal, I'm going to type cmod space 400 space ~.ssh /AWS demo.pym and hit enter. This set the permissions on my private key to only be readable by my local user. Then, copy the example SSH command from the EC2 launch window. And I'm going to paste this into my terminal window. use the arrow keys to move inside of the double quotes, and I need to tell this command the exact path to where my aws.pim file is, which is now ~/.ssh/, and then the rest will stay the same, awsdemo.pim. And now hit enter. Since this is the first time we're connecting to this instance, type yes to accept the fingerprint, and hit enter. Great! Now we're on our EC2 instance that's running in AWS. Sweet! Sometimes you might build a computer with a fancy graphics card for playing the latest PC games, and you typically don't find these in a server like this, but these chips on the graphics cards are faster at running some algorithms, such as finance models and some machine learning tasks. You select more than just the number of CPU cores and RAM when you're building an EC2 instance. It really is like speccing out your own computer. So let's go take a look at some of the different types of EC2 instances that Amazon has. From the EC2 console, let's launch another instance and take a look at the instance types again. Click on Launch Instance, and let's select the Ubuntu 18.04 image again. At the top of the list, click on the Filter by All Instance Types pull-down and look at the other available options. The general purpose instance types are good for general workloads, which are server workloads that need a balance of CPU and RAM, and they aren't heavy CPU users or they need a whole lot of RAM. The size of the instances follows the t-shirt sizes model, where an extra large is bigger than a medium, so you get more virtual CPU cores and more memory from the physical server that's assigned to your instance. Amazon has a comparison of the instance types on their website. The newer T3 and the older T2 instance types are pretty common instance types that you'll see in most AWS accounts. Now, the thing to note about the T series of instances is that they use a burstable CPU threshold. Think of this like hitting the turbo button on your Starship. When the CPU on this instance is below its threshold, such as when a T3 medium instance is running below 20% CPU usage, it will accrue CPU credits, which are like crystals that you're storing up in your warp drive. When the instance has to burst above its CPU limit, then it'll start using these crystals that you've built up. When the crystals run out, your instance can't run at warp speed anymore. There's an AWS Tech Talk that introduces the new T3 instances that goes into more detail about how the CPU credits work. If you have an application that has a consistently high CPU load, choose a compute-optimized or C-class instance, or one of the other general instances in the M class. These instances don't use the CPU credits, so you don't have to worry about that. The memory-optimized R and X classes are for workloads that need more memory, and there's even instances under the accelerated computing category that include GPUs. So if you have an application that needs to crunch a bunch of numbers, this might be the instance for you. All of these instances come with different prices, and you can use Amazon's pricing calculator to figure out your monthly pricing. I also like to use the site ec2instances.info to compare instances and pricing. You can change the cost to monthly to see some comparisons on the monthly pricing. Our instance that we just spun up is called an on-demand instance because we got it shipped to us immediately and we can turn it off at any time. Reserved instances aren't actual EC2 instances. They're billing coupons you were purchasing for an instance type. For example, when you buy a T3 medium reserved instance, you're telling AWS you would like a coupon for the monthly discount off any one on-demand T3 medium instance. And you can buy this coupon in 3 different ways. You can buy a coupon where you pay now for the entire T3 medium instance for the next 12 months. It's the biggest monthly discount, and it's like getting a great deal by paying up front for your cell phone plan. Or you can buy a coupon where you pay half up front for a whole year and ask AWS to split up the remainder each month. Or you can buy a coupon where you just pay nothing now, but you get the T3 Medium for a lower fixed rate for the next year, but you can't get out of the contract, just like a cell phone plan. You don't assign the coupon to one of your T3 mediums, it just comes off in the billing automatically. If you delete one of your T3 mediums, the coupon will just count towards another T3 medium already on your account. You don't have to do anything to reassign it. The downside is, if you have no T3 mediums running, or you changed your T3 medium into, say, a T3 large, you already paid for the T3 medium coupon, and there's no refunds. Now, there's a marketplace where you can sell your partially used coupon, but you're not going to get all your money back. Reserved instances are a great way for saving money when you know what your workload is, and it's not likely to change much over the next year. And if you've budgeted for the reserve instance rates, stay on top of your reserved instances list in the EC2 console, or use the reserved instance billing reports. When a reserved instance expires, you'll be automatically charged for the monthly on-demand pricing unless you renew the reserved instances. In your terminal window, make sure you're still connected to your new instance via SSH and type sudo space apt-get space update and hit enter. This will update the software packages list from the time Amazon took the snapshot of this Ubuntu 18.04 instance. When the packages are finished updating, type sudo space apt-get space install space Apache and the number 2, and then hit enter. When you're prompted to install these packages, type Y and hit enter to say yes to installing these packages. This will install the Apache web server, and this is the first step to setting up WordPress on a fresh Linux instance. We aren't going to go through every step of setting up WordPress on a fresh instance, but if you do want to do this, DigitalOcean has a great guide with a step-by-step walkthrough of installing WordPress this way. Now that Apache is finished installing, it's already running now on our new instance. Switch back over to the EC2 console and cancel out of the launch wizard. Click on your instance, and in the description tab that comes up, copy the public DNS. You'll notice on the left-hand column under Availability Zone that AWS selected an availability zone for us. Now, AWS automatically gave our instance a public IP, so our web server now should be accessible to the public internet. In a new browser tab, paste that DNS name that we just copied, and in front of it, make sure you put http:// and then hit enter. And it looks like it isn't working. The browser looks like it's trying to make a connection with the server, but it's being blocked, or it looks like it's failing. We need to modify the default security group that AWS set up for us. So let's dive into what a security group is and what it's doing here to block our requests. So let's say that this cable represents our external internet traffic, and we're going to connect it to our network interface so that our customers can access our web server. Now, for anyone who's run servers before or set up a home network, you would know that what I'm doing here is a pretty bad idea. This is unfiltered internet traffic, which means that unless I'm plugging this cord first into a firewall, or say a home router, or I'm running a software firewall on my server, that I'm exposing my server to attacks from hackers that are scanning Amazon's IP ranges, just looking for exposed servers, like this one. To solve this, Amazon uses security groups, which act as simple firewalls, which allow you to expose only the parts of your server that are configured for public internet traffic. Think of these as line filters on Ethernet cords going into your servers. If you do see a security group on a diagram, it's usually a black and red dashed line that's drawn around the resource it's protecting, such as an EC2 instance. Now that I've got a security group in place, I'm ready to connect back to the public internet. Let's take a look at an example diagram, and then we'll make a change to our security group. Here's an example of a diagram using the old-style icons that highlights the security groups used in each instance, but you usually won't see the security groups listed on a diagram. And here's what a security group looks like in the new style of icons. It's the red box that's drawn around the single EC2 instance. Now, we'll get into the other components you see here later, like the VPC and the public subnets, but this is what we've got configured so far. Also, I'm using a site called draw.io for creating this diagram, and if you create a new diagram, under the cloud category, the first several templates already use the new style of AWS icons. Now, there's a lot of services that do this, and you can always download the icons directly from AWS by searching for AWS architecture icons. Creating diagrams like this will help you and your team work out architectures before you build them, and they're a key component to documenting your AWS infrastructure. Back in the EC2 console, with your web server selected, under the Description tab, you'll see on the left column of the Details pane a label that says Security Groups. My instance is using a security group called Launch Wizard 2, and any security group that's called Launch Wizard was a security group that was created by the EC2 Launch Wizard, and this happened because we skipped a lot of the configuration steps. Now that's okay, because we were in a hurry to set up a server to see what it does, but in the future, I recommend naming each security group by what it does, because your account can fill up pretty fast, and it's hard to know what Launch Wizard 3 does versus Launch Wizard 12. Click on the View Inbound Rules link to get a hint of what this security group does. Okay, so this security group allows 0.0.0.0.0/0. The // here is called a net mask, and it's a shorthand abbreviation for an IP address range. So, for instance, /32 means the range is a single IP address, whereas /0 here means all IP addresses. So, this rule says that the server will accept incoming traffic over port 22, which is the SSH port, from any IP address on the internet. Okay. So now we know why our web server doesn't work, because this security group needs to also allow port 80 traffic, which is HTTP traffic, from anywhere on the internet. Click on the View Outbound Rules, and you'll see that this server can make an outbound connection with any destination on the internet using any protocol. So this means that our server can go out on the internet and get software updates or use external APIs. Click off of the modal and then click on the name of your security group. If you look on the left-hand submenu, you'll see that EC2 just jumped us down to the security group section under Network and Security, and now we're viewing more details of this specific security group. Click on the Inbound tab. Then click on the Edit button. So first off, it's not a great idea to have our SSH port publicly exposed to the entire internet. Although AWS generated a pretty strong private access key for us, it's better security if we limit the IP addresses that can talk to our server via SSH. So under the SSH rule, in the Source column, click on Custom, and then click on My IP. AWS will automatically fill in your current IP address, and that /32 means the IP range is now restricted to only your IP. If your IP changes because your ISP at home randomly switches your IPs, or you take your laptop to the coffee shop, you'll need to come back into this screen and select My IP again so it can update your IP on the security group. Click the Add Rule button. In the Type pull-down, select HTTP, which will automatically fill out this rule as TCP port 80. And for source, select Anywhere. Now this is automatically going to fill out the range as 0.0.0.0/0. Now anything using this security group will allow SSH connections from only our IP address, but allow HTTP connections from anyone on the internet. Click Save. If you still have your tab open from earlier where we tried to connect to our server, click Refresh on that tab, or on Mac, it's Command R, and look at that. Now the connection goes through, and you'll see the default Apache screen. And in just a few simple steps, you've got a working web server running off a small EC2 instance. How cool is that? Remember, EC2 stands for Elastic Compute Cloud, and the word of the day is elastic. An auto-scaling policy can tell AWS that when an event occurs, such as our instance CPU usage goes above 80% for 5 minutes, to stretch our one server into 2. And then we can tell it to shrink back down again to one server when things have calmed down again. Your application needs to be designed in a way that if 1 or 2 or 10 clones of your single server come online, that your application can load balance your traffic across all of these new servers. Now this is called horizontal scaling. If you think of a busy grocery store, the manager will open several new checkout lanes to reduce wait time. When the rush is over, they'll close those extra checkout lanes. This is different than vertical scaling, which would handle the problem by still only having a single checkout lane, but just putting a faster cashier and speeding up the conveyor belt. Vertical scaling in AWS is fairly easy. You just stop your running EC2 instance, which will cause a little downtime, and change the instance to a larger, faster server with more CPU cores and RAM. But this has its limits, and all large applications use horizontal scaling to handle an increase in traffic. We're not going to set up auto-scaling for this course, but we will create an AMI snapshot of our current running server and create a clone of it manually, which is one of the first steps to setting up auto-scaling anyway. If you'd like to dive deeper into auto-scaling, I recommend our AWS course on automation and optimization. Okay, if you're totally new to these concepts of horizontally scaling servers in your application design, search our catalog for AWS High Availability, and we have a few courses that'll show you how to keep your application running when a single server fails, or when that single server gets overloaded due to high demand. Finish out this course first though, because you're going to need to know a bit more about storage and networking in AWS to get a full understanding of the material that's presented in those courses. So, let's jump into the console, and I'll show you how to clone our existing server. In the EC2 console, on the left, click on Instances and select your running instance. Then, click on the Actions pull-down above it and take a look at a few of these options. Under the Instance State pull-down, you can stop and start the instance, and you'll also see a Reboot option. Now, if you stop an instance, you won't be charged for the compute time while the instance is stopped, but you will be charged for the storage costs of its hard drive, which are pretty minimal. You can click to start and bring the instance back up again. If you click Reboot, it'll force a software reboot of the virtual machine. Okay, now check this out. These are different actions in AWS. If you stop and start an instance, this virtual machine will actually move to another physical server in the availability zone. So do this if you're having problems connecting to the instance, because it could be a hardware failure on the AWS side. Back in the detail pane, click on the Status Checks tab. You'll notice the system status check is failing if there's a hardware failure, but it takes a few minutes for AWS to see the problem, so you might notice the problem before the alarm goes off. If you reboot an instance, it'll come up faster, but it stays on the same physical server it was on before. Okay, click on Actions again, and select Image, and then select Create Image. For image name, type AWS Demo. And you'll see an option here that says No Reboot. AWS needs to reboot the virtual machine to take a proper image of it. So this properly shuts down the file system and lets AWS take a clean image of the virtual machine, but it does cause a little bit of downtime. If you select No Reboot, well, good luck to you. Click the Create Image button, and then click Close. On the left-hand submenu, click on AMIs underneath the image header. You'll see a spinner next to our AMI while AWS reboots the instance and takes a snapshot of it. When the AMI image says that it's available, click on it and click on the Launch button. Now we're back on the EC2 launch screen, but we're launching a new server based on our server image. Select T2 Micro again, and then click the Next Configure Instance Details button. Under Subnet, select an availability zone that's different from the other instance. So my other instance was in US East 1A. So now I'm going to pick US East 1B. Click Next, and then click Next again. And then click Next one final time to configure the security group. Under Assign Security Group, I want to select an existing security group. And I'm going to select Launch Wizard 2 because that's the security group that my other instance is using. You'll notice in the rules that HTTP is now open to the entire internet. Click Review and Launch, and click Launch. This time, I'm going to choose an existing key pair, and I'm going to make sure that I'm selecting my AWS demo key pair that I used for my other instance. Select the Acknowledge checkbox, and click Launch Instances. Click View Instances. You'll see that our other instance is now spinning up. This instance is in Availability Zone 1B, whereas my original instance is in Availability Zone 1A. And I'm also going to edit the name and call this Web Server 2. Click on the new instance and click on the Description tab, and then copy its public DNS. In the new Browser tab, type http:// and paste in the DNS name. You'll see the default Apache site again because remember, this server is a clone of the server that we just set up. An AMI image is a great way to take a snapshot in time of your server in its full configuration, and then launch new instances to, say, handle a spike in traffic or restore the instance to a previous state if it gets messed up somehow. Let's leave both instances running, and we'll connect them together later in the course, but remember to come back after you're done and click on Actions, Instance State, Terminate, and delete both instances so that you're not running up your bill. Computers and servers use hard drives to store data, and virtual servers need hard drives as well because this is where they store their operating systems, server configuration files, and the source code that you'll create and upload to them to run your applications. But unlike physical hard drives in the real world, virtual drives can grow and shrink in size. You can even snapshot them at any point in time, and you can easily clone them. Amazon's primary storage service for EC2 servers is called Elastic Block Store. Elastic because it can stretch in size when you need it to. Let's take a look at Elastic Block Store in the EC2 console. When you take an AMI snapshot of your instance, you'll notice in the EC2 console, underneath Elastic Block Store and under Snapshots, you'll see that it created an EBS snapshot of your server's main drive. Now, this snapshot here is a little different than the AMI snapshot. The AMI includes everything you need to relaunch the instance, but the EBS volume is just a snapshot of its hard drive. You can create additional EBS volumes and mount them to your running instance, and this is like adding a second hard drive to your computer. You can also detach this drive and move it to another computer. Now, for backups of your server, the best thing to do is to take an AMI image periodically, because this can be easily relaunched to restore the server to a point in time. If you have an application where you need to take snapshots of a data volume that changes frequently, you might mount this as a second EBS volume and then take EBS snapshots at a higher frequency, but this is a rare case. You might do this for hosting a database server, but we'll look at some better options for hosting databases in a later video. EBS volumes are fast, which is why they're the default for new EC2 instances, but let's look at some options for sharing a drive between several instances. One limitation of Elastic Block Storage is that once an EC2 server is using an EBS volume, you can't have a second EC2 instance directly read and write to that drive. Once I've plugged this drive into this instance, there's no way to also plug it into my other instance at the same time if I need to share files between my two servers. Now, I can clone my EBS volume by taking a snapshot of it and install the clone in my other instance, but the data isn't going to stay in sync between these two instances. What you need is something similar to a NAS appliance, which stands for Network Attached Storage. And it plugs into your home network and it creates a file share where you can mount the same drive on both instances. Amazon's version of a NAS is called Elastic File System, or EFS. This service allows you to mount a shared drive across several EC2 instances to share commonly used data by your application across all of your scalable front-end servers. Now, EFS isn't as fast as EBS, because EBS sits closer to the raw hardware of your instance. So each EBS volume in your instances should include your operating system for your instance and your application source code. Your EFS drive will include anything that your instances need to share, such as user uploaded data. Okay, let's jump in the EC2 console and we'll see how this works. In the AWS console, from the Services pull-down, type EFS and click on the entry that auto-completes. Click the Create File System button. Now, it's going to create a mount point in all of the availability zones for your default VPC. We'll get into VPCs in a little bit, but for right now, I need you to remember the name of your security group and the last couple numbers and letters of it. So for me, my security group is default, and I'm going to remember 76AA4. And then at the bottom, click Next Step. At the bottom of the next screen, click Next Step again. And then click Create File System. After it's created, within this green box, it'll give you some instructions on how to mount this drive into each one of your instances. Connect to your first instance via SSH in a terminal window. You may already be connected from an earlier video. Once you're connected, type sudo space apt-get space install space nfs-common and hit enter. Type capital Y to install the packages. Now let's create a mount point. I'm going to type cd for change directory space / which will take me to my root. Now I'm going to type sudo space mkdir, so I'm going to make a directory, space EFS. Then, in the window within EFS, scroll down in the instructions, and you'll see if you're using the NFS client, it gives you a sample command. Copy that entire sample command and paste that into your terminal window. And then hit enter. You'll notice that it hangs and doesn't work. This is because our security group on our instance is blocking the return traffic from the EFS drive. In the AWS console, switch back to the EC2 console. Click on your running instance that you're connected to, and then under the Description tab, look at the security group that's assigned to this instance. You can click on View Inbound Rules to see the traffic that it's allowing. Now, we need to allow port 22 traffic to come in from this EFS mount point. With that instance selected, click on Actions, and underneath Networking, click on Change Security Groups. Now, I had you remember the last few letters and numbers of that security group ID, and this is where you're going to need them. So my EFS mount points are using this default VPC security group. And I'm going to check that, and I'm also going to assign that security group to my instance. Now I'm going to click on View Inbound Rules. And you'll see that my two security groups are now stacking on top of each other. The default security group is adding a new rule that says all ports and all protocols are accepted from anybody that's using this security group ID. This is a special security group policy, and so instead of specifying an IP range, you can grant access to ports from any resource in AWS that's using this security group ID. It's another way you can link your AWS resources together without using IP ranges, and it's very useful. So this security group will allow any instance that's using the default security group to talk to each other. And in your SSH session with your server, you can hit the up key to retry the last command. You'll notice that my drive now mounted. Now I can repeat the same steps on my other server, and anything written to /EFS will be available to both instances. Cool, huh? S3, or Simple Storage Service, was one of the first AWS services to launch, and it's like Dropbox without the downloadable clients for your computer and mobile devices. S3 buckets allow you to store images and videos and large files and share these assets directly with your users without having to configure servers and file shares like you would have done with EFS. Now, S3 is slower than both EFS and EBS, and I know it sounds similar to EFS, but with S3, you don't need a server to host your files. For example, in WordPress, you would use a plugin and tell it to store all the static stuff from the media library like blog images and videos in an S3 bucket. And then when WordPress renders your site, it'll point directly to the S3 bucket's public URL to serve those images and videos independent of your server. Let's set up an S3 bucket and see what this thing can do. In the AWS console, click on Services in the upper left, and in the search box type S3 and click on the entry that auto-completes. Click on the Create Bucket button, and for bucket name type S3 Bucket Demo. And since all bucket names need to be unique, you might have to add a series of random numbers to the end of the name just to make it unique. Select the region you've put your other AWS resources into and click the Create button on the lower left of the modal. Just like when launching our EC2 instances, this created an S3 bucket with a lot of the default settings. Click on the new bucket name. Click the Create Folder button and type Test Folder. Click Save, and then click on the test folder. Then click on the Upload button and click Add Files. I'm going to upload this image that I have of the LinkedIn logo that's included in the exercise files. Click the Upload button on the lower left. Click on the file that you just uploaded, and at the bottom of the Overview tab, you'll notice that there's an Object URL link. You can right-click and open that link in a new tab. you'll see an error message that's displayed by Amazon. Because we picked the default options when we created this bucket is marked as private, and so you can't access any of its contents from the outside internet. Any of the users on your AWS account with access to S3 can see the files in here and upload and download them, but the public internet cannot. So right now, it's kind of like Dropbox without file sharing, but you can use S3 from within your app to store user uploads securely. One of the most common methods of data breaches right now is from organizations who upload an unencrypted file to a public S3 bucket, like a database dump of all their customers' personal information. You want to be very careful with S3 and your bucket settings to make sure you aren't publicly exposing sensitive files. If you are using S3 to store private files, and you're also using S3 to store files that you want to share publicly, such as website content, I would suggest keeping these files separated into 2 different S3 buckets. Even though you can control sharing on a per file or per folder basis, I would use 2 different buckets to make sure that these settings don't cross over each other. This will prevent you from accidentally writing a policy or changing a setting that exposes your private data to the public internet. We can use the S3 console to upload and download files to our S3 bucket, but let's do something more useful with it. First, we'll need to install the AWS CLI, or command line interface, on our local computer. Now, the instructions vary whether you're on macOS or Windows, so check out the installation instructions in the AWS documentation. Once you've installed the CLI, type AWS configure. The CLI is asking for your access key that we created earlier in this course. Remember how I said to record this in a secure location because you'll only ever see it once? Well, now you need it. Paste in your access key ID. Now, paste in your secret access key. For region, set this to the AWS name of the region that you've created your S3 bucket in. Now, if you need a refresher, in a search engine, look up AWS Service Endpoints, and you should find this page in the AWS docs. My infrastructure is in North Virginia, so I'll type US-East-1 and hit Enter. For the default output format, I'll type JSON, JSON, and hit Enter. Great! Now let's make sure our access keys are working. So type AWS S3 API list -buckets and hit Enter. This will list all of the S3 buckets that we have access to, and this is the same list that you'll see from the S3 console, but it's just in JSON format. You can also type AWS S3 ls, and it'll get you the same list of buckets, but in an easier format to read from the command line. The difference between the S3 commands and the S3 API commands is that the S3 commands will give you a higher level set of operations to easily use S3 when writing command line scripts and moving files around, whereas the S3 API commands are closer to the API calls to S3 that you might make from within your source code. For now, we'll just use the S3 commands to make things a little easier on ourselves. To upload a test image from our local computer, I'm going to use the sample LinkedIn logo image, and I'm going to upload this to my S3 bucket. This is already in my downloads folder from when I downloaded the exercise files. So I'll type AWS S3 CP for copy ~downloads LinkedIn logo.png. And now I need to tell the command where I want to put this in my S3 bucket. So I'll type S3 : // and I'm going to cut and paste my bucket name from this prior command. Then I'm going to put a / to indicate that I just want to put it in the bucket's root and not in a folder, and hit enter. Switch back over to the S3 console and click on your bucket, and you'll see the file that we just uploaded. The CLI also has an AWS S3 sync command that can keep folders on your local machine in sync with your S3 bucket, and it's a great way to script automatic backups to S3 from your on-premise servers. Check out some of the other things that you can do with it from within the docs. Let's use the AWS SDK, or Software Development Kit, to interface with S3 from our source code on our server. Connect via SSH to the first server that we set up. You may already have your connection still active from the previous videos. Included in the exercise files, you'll find a text file that includes all of the terminal commands that we're going to run, so it might be easier to pull this up and just copy and paste the commands. Copy the first command, which is the sudo apt-get install line, into your terminal, and type Y and hit enter to install the packages. This command installed PHP on our server, along with several other packages that'll help get the AWS SDK installed. The second command will change your current directory into Apache's root. The third command will use PHP's composer to install the AWS SDK. Because this is just a test server, we're going to run these commands as root using the sudo command, so I can show this to you quickly, but I wouldn't recommend running all of this as the Linux root user for production systems. And if you really want to continue with the WordPress setup from earlier, follow the DigitalOcean guide, which will set up virtual sites within Apache and configure the right permissions. Included with the example files, there is a PHP file that we first need to edit and put in our credentials. On your local machine, edit this file and change the region, where it says region here, to the name of your region. Mine is US-East-1. And under credentials, where it says key and secret, and then it says key here, you need to put in your access key and your secret access key. On the line that says bucket and the value says your bucket, you'll need to change the name of this to the name of your S3 bucket that you just created. When you're done with your changes, highlight all of this code and copy it. In your terminal window, type sudo space vim space s3 test.php. And this is going to create an S3 test PHP file inside of Apache's root folder. Now we're using Vim here on the server, and I'm going to walk you through how to use this if you aren't familiar with Vim, but you're welcome to use any text editor that's available on that Linux instance. The first thing I need to do in Vim is type :set space paste. And this will put Vim into a paste mode. Make sure you hit enter, and then type I. And this is going to put Vim into insert mode. Now you can paste in your source code. After you've pasted in your code, hit escape, and now you're in command mode. Type :W, which was write for saving a file, and then type Q, so write and quit, and then hit enter. Now that we've saved the file on the server, let's run it. I'm going to type php space s3 test.php and hit enter. Once the code has run, switch back to the S3 console, and you might need to come out to this S3 root screen, and then click on the bucket name. And you might have to refresh your browser, So for Mac, it's Command R. You'll see that we have a file that's called testfromphp.txt, and this was the file that we wrote from our code. Now, using the other SDKs, such as the Python or Node.js SDKs, is very similar to this example in PHP. There's a lot you can do with this, so check out the full AWS documentation for your SDK to get an idea of some other integrations that you can use in your apps. Now that you can see how this works, you'll notice that we already stepped over the line and made a major mistake. We pasted our access keys directly into the source code, so now anyone with access to this server can assume all of our rights within AWS. Let's talk about another way to grant our code access to S3 without compromising our access keys. Do you remember that I said not to place your access keys directly into a server? Well, to get my code to work, I put my access key with all of its administrative permissions directly onto our test server. But now my access key could be compromised if anything ever happens to this server. So how do I prevent this key from getting stolen? IAM, or Identity Access Management, has a feature called roles. By creating an IAM role, I can tell AWS what permissions this EC2 instance has. In our example, I can use a role to grant read and write permissions to my S3 buckets and apply that role to my instances. Since this role is a property of the instance, it's like the instance type. There's no keys or passwords on the server that can now be stolen. Let's create a new role from our EC2 instance and fix our code. From the AWS console in the Services menu, type IAM and click on the entry that auto-completes. On the left-hand submenu within IAM, click on Roles and click on Create Role. Make sure the AWS service is selected and then click on EC2 and then click on Next Permissions. In the Policies filter box, type S3 and click on the checkbox next to Amazon S3 Full Access. This will create a role that grants full access to any S3 bucket on our account, but you can also create a custom policy that allows only read or write permissions to a single bucket if you would like. The AWS documentation has a few examples to get you started with writing a custom policy, and you can also search our catalog for AWS policy for a deep dive into writing your own policy. Click Next, Tags. Click Next again. And for the role name, type S3 Grant for EC2 Demo. And click the Create Role button. Now click on Services and switch back to the EC2 console. Click on Instances, and then click on the first instance that we created. Click on the Actions button, then click on Instance Settings, and then click on Attach Replace IAM Role. In the IAM Role pull-down, select S3 Grant for EC2 Demo, and click the Apply button, and then click Close. In your SSH session with our server, let's edit our code. So type sudo space vim space s3test.php. Now we need to remove the lines where we pass in our access key ID and our secret key. In Vim, you move up and down with the letters J and K. So I'm going to hit K to move up, and then I'm going to hold Shift and click V. And this is now putting me into visual mode. And now I'm going to press J to go down a line, J again, and then J again. So I've selected all 4 lines, and then I'm going to hit D to delete these 4 lines. I'm also going to remove the comma after my region setting. So I'm going to hit K to go up one line, and then I'm going to type capital A. So hold Shift A, which will put you in insert mode at the end of the line, and then I'm just going to hit the delete key. Now hit Escape to go back into command mode, type :WQ to save and quit, and hit Enter. Now let's run our file again. I'm going to type php space s3 test.php. You'll notice that the code still works, even without the access key, because the EC2 instance is now using the role we defined to authorize itself against S3. With any new EC2 instances you launch, you'll find the role setting in the launch wizard. So select this S3 grant for EC2 demo role, and your code will always be granted these permissions. S3 has a lot of cool features. And when I say cool, I mean ice cold. If you have older data that's just sitting around your S3 bucket, but let's say you don't want to delete it, you can create a lifecycle policy that'll automatically move the older files in your S3 bucket to a cheaper storage class within S3. And the cheapest storage class that's in S3 is called S3 Glacier. With Glacier, you're charged a fraction of the monthly fee for the files that you put in here, so it's great for server backups or for log files that you just need to keep around for auditing purposes. But just like that extra freezer that you keep around your garage, anytime that you pull your data out of Glacier, you have to let it thaw. This could take several hours, so only put data in here that's infrequently used and you're willing to accept the long wait time before you can access it again. In the AWS console, use the Services pull-down and switch back to S3. Are you starting to get comfortable jumping around in AWS to the various services? From the S3 console, click on the test bucket that we made and click on Upload. And I'm going to try to upload the LinkedIn logo again. But this time, click Next. On this screen, you can set permissions on the file. But for our demo, click Next. Here, you'll see the different storage classes that S3 has. This chart on AWS's website gives you a pretty good overview of the differences in the storage classes and how many availability zones your data is going to be replicated into for redundancy. You'll notice that the one zone storage class is only replicated into a single availability zone. This storage class is really good for third redundant copies of your on-premise backups because it's kind of cheap and you can get your data back faster than you can with Glacier. But since it's your plan C or hopefully plan D in a data redundancy plan, you don't need it replicated across a bunch of availability zones and protected against failure like your other data. Hit the Close button, and we won't upload this because it's such a small file. It's kind of a waste to put this into Glacier, but you can see here where the options for storing things into Glacier are. On your test bucket, click the Management tab. Here, you can create lifecycle policies that automatically move older files in your S3 bucket to a cheaper storage class, and then maybe even eventually delete the files entirely. On the Properties tab, you can see a few of the other features of S3. Versioning lets you keep point-in-time versions of your changed files. Static website hosting lets you host an entirely static website directly from an S3 bucket. If you use GitHub pages, it's sort of like that, but a little more basic, where you can use a static website generator like Jekyll to host a simple blog or marketing site without Node.js or WordPress or databases. Search our catalog for AWS S3, and you'll see a number of videos that walk you through static site hosting and lifecycle management if this is something that you'd like to use. The Permissions tab will let you control public access to your bucket, but I can't stress enough that you really need to stop and read the documentation here and observe the warnings. Be careful to not publicly expose your database backups to the entire world. Search our catalog for S3 policies, and you'll find some additional resources on how to safely open up permissions to your S3 bucket. So we already know that you can use an S3 bucket to host the static content for your website, like images and videos. With CloudFront, you can push the contents of this S3 bucket to edge servers all over the world. So if you have users in Ireland, your videos will load faster for them because they're being served a local copy from the Ireland data center. Now your users in Tokyo or your users in Brazil will be served content from the data center that's closest to them. CloudFront is a content delivery network, or CDN, that can mirror your S3 bucket all across the world, and it's a lot cheaper than a plane ticket to Tokyo. Go back to the landing page in Amazon S3 by clicking on Amazon S3 in the upper left. Click the Create Bucket button, and let's give your bucket a unique name. I'm going to put the word public in my bucket name so I remember that this is a public bucket, so that anything you place in here, it might be publicly exposed to everyone. My bucket name is going to be public S3 demo CloudFront test. And then I'm going to click Next. I'm going to click Next again. And on the permissions screen, uncheck the Block All Public Access checkbox, which will now allow this bucket to contain items that can be exposed publicly. Click Next. And click Create Bucket. Click inside of your new bucket and click the Upload button. I'm going to upload the LinkedIn logo from the exercise files. Now, we're using a static image here, but you can use HTML files or an entire folder of statically generated content and host an entire website here. Click Next. And then, on the Manage Public Permissions pull-down, select Grant Public Read Access to this object. Now, Amazon is warning us before we do this that this object has public read access and everyone in the world can read this object. In fact, before we click the next button, let's take a small moment to scroll through the S3 wall of shame and look at all the companies who just ignored that warning message. See, Dow Jones, Verizon Wireless, Time Warner Cable, the Pentagon. Okay, great. So you might see a few companies in here that you recognize. So now that I've scared you a little bit, let's go back to S3. Click Next. Click the Standard Storage class. Click Next again, and click the Upload button. If you click on the file, you'll see a link to this file that you can open in a new tab. You should see the LinkedIn logo. Great! Now that we have a public S3 bucket that we can use, let's use CloudFront to replicate this bucket across several edge locations for speed and redundancy. Click on Services from the top and type in, you got it, CloudFront, and click on the auto-completed entry. Click the Create Distribution button, and then under Web, click Get Started. Now, this screen can be pretty overwhelming, but it's actually pretty straightforward. In the Origin Domain Name field, click inside of it and it'll auto-populate with your S3 buckets. Click on the S3 bucket that we just created. And scroll to the bottom of the page and click on Create Distribution. Now, it's going to take a few minutes for CloudFront to push this bucket out to all the edge locations, so its status is going to say in progress. After you've waited for a good 5 minutes, look at the domain name column and copy the domain name that was assigned to our CloudFront distribution. In a new browser tab, type http:// and paste in the CloudFront domain name. Then type /LinkedIn logo.png because we need to match the path from our original S3 bucket. Then hit Enter. And there's the logo. Now we've sent the LinkedIn logo all across the world via CloudFront. CloudFront is great for static content, and if your web application uses React as a front end, your React builds can get rather large, and so pushing it to CloudFront will let your users get that initial download faster, and they'll spend less time looking at a spinner waiting for your web app to start. Just as AWS has virtual servers and virtual hard drives, AWS also has virtual networking components. In the real world, if I had two computers that I wanted to talk to each other, I would plug an Ethernet cord into the networking card of each computer, and then I would plug the other end of that Ethernet cord into a networking switch. At home, you may also have an internet router that these would plug into, and that router has a 4-port switch built into it, which works the same way that this dedicated switch does. Now, if I put a private non-routable IP address on each of these computers, such as 192.168.1.2, and then let's say on my other computer, I give it 192.168.1.3, then these two computers could share files over this private network. Notice that I haven't yet connected external internet to either computer or to the switch. In AWS, the network that we just created is called a virtual private cloud, or VPC. Here's the old icon for a VPC. Your EC2 instances still have security groups on them, and those still take priority, but your instances will also sit within a VPC with private networking addresses, which will allow your servers to talk privately with each other without traversing the public internet. A VPC is indicated on diagrams as a box that is drawn around the components within the VPC, and the upper left border of the box will have either the new VPC icon, or, as you can see here in the scenarios and examples portion of the VPC documentation, the old VPC icon. There are several VPC scenarios laid out in the documentation, and number 1 and number 2 are probably the most common. Scenario number 1 is a single VPC with 2 subnets, and each subnet exists in a different availability zone. This is similar to what AWS created for us when it set up the default VPC for us. Scenario number 2 is a common setup for a fleet of servers, and the difference here is that one subnet is a public subnet, and the other is labeled a private subnet. Public subnets are subnets that divide up your VPC IP range, and they handle traffic from the open internet, like the fleet of web servers that are indicated here on the diagram. The private subnet hosts your instances that you want to fully protect from the internet, such as your database servers, indicated here as blue EC2 instances. Traffic can pass between your subnets, but the public internet shouldn't be able to access any servers in the private subnet. Let me show you the first few steps on what setting up Scenario 2 looks like. In the AWS console, click on the Services menu and type VPC and click on the entry that auto-completes. Click on Your VPCs and click on Create VPC. For the name, type Test VPC, and for the CIDR block, type 192.168.0.0/16. Now the /16 is the net mask, and this is shorthand for saying that the IP range of our VPC is going to go from 192.168.0.0 all the way to 192.168.255.255. Click Create and click Close. On the left-hand menu, click on Subnets and click on Create Subnet. A subnet chops up your VPC's IP range into smaller sections. For name, type public-A, and in the VPC pull-down, select the test VPC that we just created. Under Availability Zone, select Availability Zone A. And for the CIDR block, type
192.168.1.0/24. So the net mask of /24 will indicate an IP range of 192.168.1.0 all the way to 192.168.1.255. Now click Create and click Close. This is how you would create a new VPC and a subnet within that VPC. If your eyes are starting to glaze over a bit, but you know this is something that you'll need to set up to protect these database instances, check out our course called Amazon Web Services Networking, which will go further into VPCs and setting up subnets.
Your router at home creates a private network, much like a VPC, that links all of your local computers and devices together, either through wired connections or through wireless ones. It then routes traffic from the public internet to your private network through a technique called Network Address Translation, or NAT. This allows your wide area network interface to get a single public IP address from your internet provider, like 1.2.3.4, and to share that IP address to all the devices on your local area network, or LAN. So when one of your computers, such as 192.168.1.2, goes to a website like LinkedIn.com, the servers at LinkedIn will see traffic coming from the WAN interface at 1.2.3.4. And then when LinkedIn responds, the return traffic is sent to 1.2.3.4 and it's routed by your router back to the originating computer at 192.168.1.2. Now, if some random person on the internet, such as 5.6.7.8, wants to reach one of your private devices, it's going to try to open a connection with 1.2.3.4, which is your WAN interface, and then your router will drop the traffic because it doesn't know which computer on your private network it needs to route this traffic to, because no private device first talked to 5.6.7.8. With NAT, think of your router like a door with a single doorknob on the inside. Your computers inside the network can turn that doorknob and open the door, which will allow two-way traffic to pass with whoever they just contacted. But once that door closes, traffic from the outside can't get in because there's no doorknob on the outside of the door. In AWS, this is called a NAT gateway, and it attaches to your VPC and it creates a door to the internet that can only be opened from inside the VPC. Now your instances can have internet access to reach other services and to download software updates, but no one on the public internet can get to your instances. This is a great way to secure internal servers, such as database servers or file shares, from outside attacks. But if you need to run a public server at home, like a web server, the only way to get around this limitation in NAT is to go into your router settings, usually turn on a feature that's called port forwarding, and then that will tell the router to always route certain types of public initiated traffic to a specific computer on your private network. And you might have done this before if you were hosting a game server for your friends. Now, the door to your router has a doorknob on both sides, and it can be opened from either end. Now, in AWS, this is called an internet gateway. Unlike a NAT gateway that only has a doorknob on the inside, an internet gateway has a doorknob on both sides, and it allows traffic originating from the public internet to open that door and to route to instances within your VPC.
In the VPC console, on the left, click on Internet Gateways. Now, one was already created for us by the default VPC, and Amazon already did all this for us. In the AWS VPC documentation, this is the Internet Gateway of Scenario 1. To get to the configuration listed in Scenario number 2, in the VPC console, on the left, click on NAT Gateway, and then you would click on Create NAT Gateway. Now, Here, you'll select your private subnet in the first pull-down, and then an Elastic IP in the second pull-down. To go back to our home router example, this is the IP address that your NAT gateway is going to use on its WAN port. So when your private subnet servers turn the doorknob and open the door from the inside, they will talk out to the public internet using this Elastic IP address. So the public internet will only see traffic coming from a single IP, even though you could have several servers behind the NAT gateway. And this is just like how your router works at home. Now, let's look at what an Elastic IP address is.
Because we told AWS that each of our instances could have a public IP address, AWS randomly assigned a public IP to each of our servers, which is written here in red. And now our computers are accessible from the public internet through the internet gateway that they created for us. But the only catch with these public IP addresses is that if you stop the instance, which is kind of like pulling power to the server, and then you start it back up again later, it's going to go to Amazon's pool of IP addresses and get a new public IP. Now, if you've hard-coded your IP address anywhere, such as in your DNS records, which we'll get into DNS later, then you'll need to go through and update everything with your new public IP address. Now, if this happens randomly in the middle of the night, which it can, especially if AWS is trying to recover an instance due to a hardware failure, then your site's going to be down until you get up and make your DNS changes. It's like waking up one morning, going out to check your mail, and realizing that the post office changed the house number on your mailbox. If you need this public IP address to stay the same, regardless of what happens to this instance, then you'll need to request an Elastic IP. Elastic IPs come from Amazon's pool of IP addresses, but they're bound to your AWS account instead of being temporarily tied to a single running instance. You then assign your Elastic IP to your running instance. But if you choose to terminate your instance, this Elastic IP is going to stay on your account and can be assigned to another instance in the future. But because the internet is running out of IPv4 addresses, they are a precious resource, and Amazon will penalize you with a small fee each month for keeping Elastic IPs on your account that aren't in use. So, if you terminate your instance, make sure you release its Elastic IP if you have no further need of it, because you will be billed for it if you don't.
You can manage your Elastic IPs from the VPC console, and you do this to request an Elastic IP to bind it to a NAT gateway. On the left, you would just click on Elastic IPs. But you can also request an Elastic IP from the EC2 console and then bind them to EC2 servers. This will replace the public IP address that AWS randomly assigned to your running instance, and now it'll be a fixed IP that won't change when you stop and start your instance. In the Services menu, jump over to the EC2 console. On the left-hand menu, under Network and Security, click on Elastic IPs. Click Allocate New Address, and click the Allocate button. And that's it. Now we've got an Elastic IP. Click Close. Now remember, we'll be billed for this Elastic IP unless we bind it to something, like a NAT gateway or an EC2 instance. You can see from the Elastic IP table here that there's not an association ID or an instance ID listed for this Elastic IP, so it's not bound to anything yet. If you end up with a ton of Elastic IPs for some reason, you need to periodically review this table and release any Elastic IP that isn't in use. To do this, you select the IP, and then you click Actions and click Release Address. Now to bind it to an instance, in the Actions menu, click on Associate Address. For the instance, select our Web Server 1. Select the only private IP that's listed on that machine, and then click Associate. And then click Close. On the left-hand side, click on Instances, and click on Web Server 1. And you'll notice that the Elastic IP is now the public IP address of this machine. Now, our public IP just changed on this instance, so if you still got your SSH session running on the server, it just got terminated. You need to click on the EC2 instance again, click on Connect, and update the example SSH connection command to connect to this server. There's two main use cases for using a VPN, or virtual private network, with Amazon Web Services. The one that is most relevant to developers is called AWS Client VPN, and it allows you to use a VPN client on your home or work computer to establish a secure connection with your VPC. So if you went with a VPC configuration where you have a private subnet and you placed your database instances inside of that private subnet, then because the NAT gateway only has a doorknob on the inside, it'll also prevent you from establishing a connection with your own database server from work or home. So you wouldn't be able to use a database editor installed on your machine, such as SQL Server Management Studio or MySQL Workbench. And if you need to develop your source code locally and connect to a development database that's in a private subnet, your code couldn't make that connection. One way around this limitation is to use the AWS Client VPN and establish a secure tunnel from your local computer directly to your VPC. So now you've created a secure side door into your VPC that only you and other authorized users can access. The other main use case for a VPN with AWS is called a site-to-site VPN. A site-to-site VPN is one of the ways that you can bridge your existing on-premise data center network with your VPC. In the AWS VPC documentation, this is scenario number 3. You would use a site-to-site VPN to securely move your data up to AWS as a part of a cloud migration, or you would use this in a hybrid model where some of your on-premise infrastructure continues to serve your application, but you start using more AWS services to support your on-premise application.
In our discussion on autoscaling, I had you imagine that you were at a grocery store, and then when the checkout lanes started getting long, autoscaling would open up more checkout lanes by scaling up the number of instances. Sometimes, when lanes start getting really long, the grocery store will have an attendant walk up and down in front of all the checkout lanes, so that attendant will direct you to which checkout lane you should go to. In a networking world, that attendant is called a load balancer, and it splits up the incoming traffic and balances it among your healthy servers. It's a key component to horizontal scaling, and in AWS, this is called an elastic load balancer. Let me demonstrate how a load balancer works. Now, this isn't an actual load balancer. They're much larger, and some just don't look any different than a rack-mounted computer, but this little hub will make it easier to show you what a load balancer does. You point your users at your load balancer, and the load balancer will then forward that traffic onto any healthy server. If you need to scale up, you add an instance to your load balancer, and it'll start directing a share of the traffic to that new instance. If it detects that one of the servers isn't healthy, it'll stop directing traffic to that server. And you can also tell it to take a healthy server out of rotation, such as when you need to perform maintenance on that server. If the grocery store attendant knows that the cashier on lane 1 is about to go on break, they'll stop directing customers to lane 1, and that cashier will check out the remaining customers and then close their lane. Likewise, a load balancer will stop sending new connections to a server and let it drain its remaining connections before going offline. Let's set up an Elastic load balancer so you can see how this works.
In the EC2 console, on the left-hand submenu, click on Load Balancers. Click on Create Load Balancer. Network load balancers are really fast, but they don't have many features because they achieve that speed by not looking too closely at the traffic coming in. Application load balancers are great for web traffic because they'll look at the incoming traffic and route it based on a set of rules. Under Application Load Balancer, click Create. For name, type Test ALB. Leave the Listeners section at its defaults, but these are the ports that you want your ALB to listen on and forward to your target servers. For availability zones, select the default VPC that AWS created for you. It's usually called default and it always comes with a new account. And then, underneath the availability zones, select the two availability zones that your two instances are running in. For me, that's Availability Zone A and Availability Zone B. Click Next. Now, we aren't setting HTTPS up right now, so click Next again. Load balancers use security groups, just like EC2 servers do, so there's a filter on the internet line coming into your load balancer, just like your EC2s. Select Create a new security group. Now, I'm going to leave all of this as default, but for any ports that your load balancers listen on, you also need to allow those same ports in the security group. Click Next. Load balancers route their traffic to target groups, which include your target servers. For name, type Web Servers. These default settings say that ALB is going to route its incoming traffic, which is coming in on port 80, to port 80 on the target servers. ALB will use health checks to determine that a server is healthy before sending traffic to it. You might have a specific page in your application that you want ALB to check, but the root of our site is fine, so leave these settings the same and then click Next. Now we are registering the target servers to the target group that we just created. Click the checkbox next to both instances and then click the Add to Registered button. Then click Next Review. Click the Create button and then click Close. In the Details panel of our new load balancer, click on the Listeners tab. And under the Rules column on the port 80 line, click on the Web Servers Target Group. In the Web Servers Target Group Details pane, click on the Targets tab. Since we just created this load balancer, the status of each of our target servers is set to Initial because it hasn't completed the health check yet. After several minutes, click the Refresh button at the top of the page. Great, now our servers are listed as healthy. On the left-hand menu, under Load Balancing, click on Load Balancers again. In the description of our test load balancer, copy the DNS name. In a new browser tab, type http:// and paste in the DNS name that you just copied. Look at that! It works! Now our load balancer is shuffling the incoming port 80 traffic to both healthy servers. If you want to see some other things that ALB can do and see how you can set up HTTPS for secure traffic, check out my other course called ECS and Multi-Region Load Balancing. So we just set up an application load balancer to balance the web traffic to our healthy instances. But we don't want our users going to that long and ugly URL that AWS gave us. We want to use our own domain name. DNS, or Domain Name System, it's like the phone book of the internet. It takes a domain name like LinkedIn.com and it looks up the IP address. Because telling your colleagues to connect with you at 108.174.10.10, it just doesn't sound as good as saying, hey, connect with me at LinkedIn.com. AWS has a DNS service that they host, and it's called Route 53. And it's easy to remember because the internet standard is that all DNS servers communicate over port 53. And here's the old icon for Route 53, which looks like, well, I'm not really sure what that looks like. Route 53 isn't just a regular DNS hosting service like GuardDuty has for linking a domain name to an IP address.
it has additional features and routing options for traffic that's headed to AWS servers. And that can help you with scalability and increasing the uptime of your app. Let's go set up Route 53 with a domain name.
In the AWS console, click on Services and type Route 53 in the search bar and click on it. Now, you don't have to park your domains at Route 53 to use the service, so if you use GoDaddy or another registrar, you just have to point your DNS servers at Route 53. The AWS docs list how to do this. If you don't have a domain name yet, Route 53 will register one for you. Click on Hosted Zones, and click on Create Hosted Zones if you're bringing in a new domain name. Now, I already have one, so I'm going to click on it. These are all my DNS records, so the root of my domain currently points to an IP address, and www.halvanta.com also points to an IP address. I want to point these at my load balancer, so I'm going to click on my root A record here, and I'm going to click on Yes to Alias, and under the alias target, I'm going to click inside the box and select my ELB load balancer. Click Save Record Set. So now halvanta.com points to my application load balancer. Under my record for www.halvanta.com, I'm going to click on it and I'm going to say, yes, I want to create an alias. And I can create the alias target to the Elastic load balancer that I already have, or you can actually point an alias to other records within this domain. So I'm going to create an alias to the other A root record, which is halvanta.com. And then click Save Record Set. So now www.halvanta.com actually points to this same record up here, which points to my application load balancer. Now, it might take a few hours for the DNS to update itself, but usually this will happen within 5 to 15 minutes. Okay, so now I waited a little bit for the DNS to refresh itself, and now in my browser, I'm going to go into a new browser tab and type http://halvanta.com and hit enter. There we go. My domain at Route 53 is now pointing to my application load balancer, which is sending me to one of my healthy servers. In my ECS and multi-region load balancing course, I cover Route 53 in a lot more detail, so check it out if you want some more information on how DNS works and you want to find out how you can use Route 53 to send traffic to another AWS region during a regional failure.
AWS has a lot of services for helping you manage databases, and this can be pretty overwhelming. Having a cloud vendor help you manage the servers and backups of your data is called Database as a Service, or DBaaS, and it lets you focus on the data itself and optimizing retrieval versus configuring failover and managing database engine updates. If you are migrating an existing application into AWS, then your database technology has already been chosen for you, either by your development team or by the vendor who created your app. And so I would recommend looking at the AWS Data Migration Service, which can take your on-premise relational database and create a real-time in-sync clone of your database in the cloud so you can perform a smooth transition from your on-premise data center into AWS. Now, if you're building a new application or re-architecting an existing application, choosing a database provider can be complicated. Before you start having an internal war with your team about whether to use an Oracle database or a Postgres database, I would back up and look at the data needs for your whole application. What kind of data will you be storing? How much data do you currently have? How much data will you write to your database over the period of, say 1 hour? How much data will you read? Will you be running a bunch of large queries and reports? What kind of uptime do you need? Ask some higher level questions first, and then design a database solution around those broad categories. If you're going to store a lot of historical data for reporting, I don't know, maybe you need a big data solution. But if you need real-time access to a current month of data, maybe you just store that in a relational database and then move the rest of it into a big data store later. If your relational database is going to ingest a large stream of data, maybe you need a queue that sits in front of the relational database that aggregates some of the data over, say, like a 5-minute period, and then it only inserts the aggregated data into the relational database. If the data types that you're storing are object-based and you don't need a lot of reporting, maybe it's better to use a NoSQL database. Once you know the broad strokes and identified the larger pieces of how it's all going to tie together, then you research which relational database would be good for your application based on feature sets and budget and things like vendor support. There are not right and wrong answers here when choosing database vendors, but there's only good, better, and best for your specific use case. But using the wrong type of database technology in the wrong way can really hurt your app going forward. Relational databases are not a good substitute for a big data store, and vice versa. Even if you're familiar with database types, I would recommend you read the book Designing Data-Intensive Applications. It doesn't favor one specific database engine, but it talks about the broad strokes and how the database technologies all differ from each other, and when is the right time to employ each strategy. Most of my experience is with relational database engines, and this book really helped me fill in some gaps in my own knowledge. Getting this higher perspective on how to store and process data within your app will help you select between all of the various services that AWS offers for storing your data. Now, let's look at what AWS can do for us. If you have a relational database like MySQL or Microsoft SQL Server, you can always spin up an EC2 instance and install the database engine directly onto the server. If you're coming from an on-premise environment, this is probably how you already configured your servers, and AWS will let you replicate that same environment in the cloud. However, just like your on-premise environment, you may not have responsibilities over the hardware anymore, but you're still responsible for all the configuration, the operating system updates, the database engine updates, the monitoring, setting up failover replication in case your database instance fails, and, the list goes on and on. So to help you out, AWS has a managed platform where you just give them your database and they do all this for you. They manage the EC2 instances, the database backups, the database engine upgrades, even the failover replication. This service is called Relational Database Service, or RDS. RDS supports most of the popular relational databases, such as Postgres and MySQL, SQL Server, and Oracle. Let's dive into a few ways that you can use RDS.
This is the RDS console, and I'm going to launch a Postgres cluster just so that you can see what some of these settings look like. Similar to launching an EC2 instance, you select a t-shirt size for your database instance. Now, you can start small and increase the size of your instance as you scale up. However, you can't scale back down. If you need to scale down, you'll need to launch another smaller RDS instance, transfer your data, and then change your database connections in your code. So start small and scale up only when you need to. If you select the multi-AZ deployment option, RDS will create a second database instance for you in another availability zone within this same region and automatically configure the cluster for you. Now, if you're running a production database that needs a high uptime, I would highly recommend using multi-AZ, but it does double your cost because now you're running 2 instances instead of 1. Although in RDS and in your code, you were still only ever going to connect to the 1 cluster endpoint. If you have the multi-AZ option enabled and you need to make changes to your cluster, like provisioning more disk space or going to a larger instance, you'll likely not experience any downtime from these changes because RDS will make changes to the secondary database first, swap the cluster, and then make changes to the primary database instance. You can always start in a single availability zone, and then, as your uptime needs increase, turn on multi-AZ later and tell RDS to provision the cluster in the middle of the night so that you reduce the impact to your customers while it's performing this change. Another thing to note here is that if you choose to restore your database instance from the backups to a point in time in the past, RDS will create a second cluster for you. It won't restore the backups on top of your existing cluster, which is different than how restoring a database works from an on-premise environment. You can manually move data between your new cluster and your existing cluster, and then just delete the new cluster when you're done with your repairs. Or if you want to use the new cluster as your main database endpoint, it'll come up with a different database connection string because it's a new cluster. So you'll have to change these database connections in your code to roll the entire cluster back to a point in time. RDS is great, but you still have a few database administration tasks you have to perform, like keeping some monitors on read and write throughput. If the thought of this scares or just bores you, look at Aurora. Aurora works very similar to MySQL or Postgres from a developer standpoint. However, it's a service where even more of the server management is handled by AWS, and it'll even run in a serverless model where you don't even manage the instances at all. So if you want to be as hands-off as possible in managing your MySQL or Postgres workloads, or you are picking a relational database for a new project and you don't want to have to deal with anything even remotely close to the engine room, look at Aurora. AWS has a great page that breaks down the terminology around NoSQL databases and shows the different NoSQL databases that they offer. A NoSQL database is just what the name implies. It's usually a database engine that isn't a relational database type that doesn't use the standard SQL query language. There's NoSQL. Instead of imagining the data being stored in a tabular form like a spreadsheet with fixed data types for the columns, NoSQL databases are great for storing data in a schemaless format. Instead of a mail slot that only accepts postal letters, it's like a package delivery locker where each cubby can fit anything that you want and they all store different things like shoes or footballs, a candy bar, whatever. The most popular key value store that they offer is called DynamoDB, and it's pretty easy to use. So this exists higher up in the database as a service offering where you really don't do any management of it. You just pay for what you use, and if you partitioned it correctly, it's easier than the RDS offerings to scale up and down. Another really great feature of DynamoDB is global tables, which let you replicate your data across several regions for speed and redundancy. And you don't have to do anything complicated for cross-regional replication if you need that kind of uptime and performance. I recommend you search our catalog for DynamoDB because we've got a lot of in-depth dives on how this works, and I walk through partitioning and global tables in my other course, ECS and multi-region load balancing. One of the databases that popularized NoSQL databases is MongoDB. DocumentDB is a database platform that's Mongo-like, but you don't have to deal with servers and Mongo clusters, although if you do need to run Mongo directly from AWS servers, there's a white paper in the docs on how to do this.
When the database has to look up data, it can be slow. And if you need to keep looking up the same piece of data over and over again, it can really slow down your application. Some databases are used like scratch pads, where you can just look something up from your database and then you just write it down real fast on your scratch pad, and then you don't have to keep looking it up each time. In-memory caches can do this for you, and to help you deploy one of these, AWS has created Elasticache. Elasticache will help you manage and deploy two of the most common types of in-memory caches, Memcached and Redis. Redis is the more popular in-memory cache, but I've used Memcache because it's supported by a few PHP open source apps. Now, you can always install Redis or Memcache directly on some EC2 servers and set all this up yourself, but AWS has simplified a lot of the management of these services with Elasticache. Not every application will need an in-memory store, and to learn the right use cases, I would refer you back to the Designing Data-Intensive Applications book. If you think you might need this for your project, search our catalog for Elasticache, and we've got a few walkthroughs on how to set one of these clusters up and tie it into your app.
Redis is the more popular in-memory cache, but I've used Memcache because it's supported by a few PHP open source apps. Now, you can always install Redis or Memcache directly onto some EC2 servers and set all this up yourself, but AWS has simplified a lot of the management of these services with Elasticache. Now, not every application will need an in-memory store, and for the right times to use an in-memory cache, I would refer you back to the Designing Data-Intensive Applications book. If you think you might need this for your project, search our catalog for Elasticache, and we've got a few walkthroughs on how to set up one of these clusters and tie it into your app.
When you have a lot of data and you need to be able to search and report on it, you'll want to look at a big data store. One of the more popular services AWS has for this is called Redshift. Now, before we get too far into big data, there's some terms that we need to sort out first.
The first term that we'll look at is a data lake. A data lake is like a box of books at a thrift store or in a garage sale. It's just a place where you just stash a huge amount of data and you don't have it sorted or really organized in any particular way. In AWS, this is usually gigabytes of text files stashed into an S3 bucket, and it could be logs from your web servers or raw telemetry data or logs of user events within your app. On the other hand, a data warehouse is organized and it has a fixed data type, and it's usually stored in a relational database. It's not a mound of books on the floor, it's a library. It's a well-organized bookshelf, and everything is labeled and alphabetized. For large amounts of data going into a data warehouse, there's Redshift. Underneath the hood of Redshift, it's a heavily modified cluster of Postgres servers. So if you've got so much data that regular Postgres would just slow to a halt when you try and run a query, you'll want to use Redshift instead. Search our catalog for some examples of setting up Redshift, but I also highly recommend this AWS Tech Talk titled Deep Dive on Amazon Redshift, because they go into a lot of detail of how to correctly configure Redshift for your data workload. Also, the AWS docs have several tutorials that you can walk through on Redshift, and I would highly encourage you to walk through these tutorials, especially the tuning table design, before you decide if Redshift is right for you. If you're already using Hadoop or Apache Spark, Amazon EMR is like RDS or Elasticache for these data stores, in that it makes it easy for you to manage the servers that runs your big data cluster. If you have a bunch of text files in an S3 bucket, which is a data lake, and you need to do some queries against this data, look at Athena. Now, we've got courses that cover all of these topics, so search our catalog for big data or any of the AWS big data services to learn more.
When new data needs to be written to your database engine may place a lock or a hold on the table that you're writing to. And this is going to prevent other users from reading from that table until you're done writing your new data. Now, when you have a lot of data streaming into your database, this wait time on reading from the tables can really slow down your application. A queue can temporarily store the data that you need to write, so that a spike in incoming data doesn't cause your database to melt down. This means that your application's users aren't sitting around waiting on your database, so they can move on and keep using the rest of your app, and their data will be written later. This is just one use case for a queue, and there's several other use cases, such as creating a messaging framework to help the components of your app talk to each other without relying on the database for this. In AWS, two such services for creating a queue are Kinesis and Simple Queue Service. Kinesis is able to handle a large stream of incoming data, such as real-time data on what your users are clicking on in your web application, or streaming of real-time application logs from your servers. It's also able to connect to other services to do real-time reporting on these large data streams. SQS is more popular and it's simpler to use, hence its name, Simple Queue Service. But it can get expensive if you're sending it lots and lots of events, which is one reason why there's Kinesis. Simple Notification Service, or SNS, can be used to push out a message, such as an email or text message, or an HTTP call to a webhook. So after your SQS queue has finished generating the report they were waiting on, SNS can send them an email and let them know that they can log back in and download their report. All the messaging services work a bit differently, so it's important to understand when to use the right tool for the right job. The question isn't, how should I choose between Kinesis or SQS or SNS? Like you're somehow choosing between cereal boxes at a grocery store. No. The real question is, when should I use Kinesis or SQS or SNS? Because you might use Kinesis to buffer your incoming data, but then also use SQS at the same time from one of your Kinesis workers to kick off a separate workflow when only certain events come into your Kinesis stream. If Kinesis is a nail gun, then SQS is a hammer, and you wouldn't use your nail gun to hang a picture. But if you're replacing a roof, you'll need both tools. This middle part of the ship falls under the label of Platform as a Service, or PaaS. And although you still provide the code, AWS will do more of the work of managing servers, so you don't have to get your hands dirty in the engine room while connecting directly to servers to update the operating system and running terminal commands to configure new services and junk like that. One of the first services that we'll look at is called Elastic Beanstalk. But before we move into the Platform as a Service section, and even beyond that, some of this can seem like you just click a few buttons, you upload your code, and magic happens, and your app just works. But behind the curtain, AWS is still using the same EC2 instances, storage, and networking components we've already explored. You will not see any of this. In fact, you're only going to interface with this small thing. But when you're troubleshooting problems or architecting new solutions to run on these higher platforms, it can help to think about how all this is going to wire together and run on the virtualized infrastructure as a service layer that it sits on.
Elastic Beanstalk is great if you have a single code base for your project and you just want to give AWS your code and let them do more of the work of managing the servers and the operating system updates. Underneath the hood, it's still EC2 servers, but it's great for developers who don't have the time for running operating system updates. Elastic Beanstalk is one way we can host our WordPress marketing site, and AWS has a tutorial in their docs about how to do this. Now, there's some trade-offs to this architecture that they propose, such as you can't update WordPress using the WordPress admin, so read through this doc and see if this solution is right for you. If you are used to hosting WordPress from a shared host like GoDaddy or Bluehost, you usually pick a dedicated hosting plan based on your needs. If you want an experience similar to what you would get with one of these hosts, look at Lightsail. Its interface and user experience are similar to what you would get with another web host, and it's a great way to bring a site into AWS if you're used to using cPanel for managing your web host. If you outgrow the limitations of Lightsail, it's got a built-in upgrade path for your site that'll transition you to your own EC2 instance if you decide in the future that you'd like to move your site back down to the engine room and control more of it yourself.
Containers can be used to take a large monolithic single application and break its features down into smaller microservices that can be easier to scale, monitor, and maintain. So instead of my large monolithic app, let's say I've got a microservice container that handles the signups for my app, maybe one that handles the payments for my app, and maybe another one that handles all the reports for my app. Now, if you're new to the world of containers or you've only briefly heard of technologies like Docker, think of a container like a mini virtual machine. Although it's not technically a virtual machine like your EC2 instances, imagine it more like its own little computer, like a Raspberry Pi, where all of your application software dependencies and libraries are already installed and configured, things like Node.js and Python, and all your code is already set up. And just by, say, plugging it into your container host, your app immediately starts and runs with no setup on your part. Now, if this talk about containers has piqued your interest, search our catalog for Docker or microservices, and we'll walk you through hands-on examples so you can use these concepts in your apps. Now, AWS has gone container crazy, and they have several platforms to help you host your containers. But the most popular service they have is called Elastic Container Service. Let's dive into this some more.
Similar to RDS and Elastic Beanstalk, ECS will control EC2 instances for you, so you don't have to worry about setting up your own clusters and doing a bunch of server administration tasks. So you can just focus on your containers and creating a microservices code architecture. Containers are spawned from a container image that has to be hosted from a repository like Docker Hub, which is like Git for containers. Elastic Container Registry gives you a place to put your container images, but you can still use another registry service like Docker Hub if you like. Containers can be configured in two different ways. You can stash an entire web server into a container, like Node.js, and when you launch that container, you'll want that container to continuously run so that the web server can listen for incoming traffic and return responses. Or you can have a container that only performs a single task, and when it's done, it stops executing. This could be a container that starts up, pulls in an image, maybe does some resizing on it, and then writes out the process imaged and it exits. When setting up your ECS cluster, you select a launch type for your containers. If you have workloads that need to run continuously, select EC2 instances, which will spawn some EC2 instances for you and control them via the ECS console. If you have workloads that execute once and then are done until called again, select Fargate. To set up your own ECS cluster that's powered by EC2 instances, watch my other course on ECS and multi-region load balancing. If you want to see what Fargate can do for you, check out my course on Fargate in GitLab.
As a subset of the Platform as a Service offerings, or PaaS, a new category has come about called Functions as a Service. Now, containers have all this extra tooling around them where you need to define what your dependencies are, build them into the container, and then tell the host what kind of resources your container needs, and all this extra stuff just surrounds the actual source code that you want to run. So Amazon thought, could we make containers even easier? Instead of giving us the container and configuring ECS for how to spawn multiple copies of the same container, can people just give us the actual code inside of here that they want to run and just let us, figure out the rest? Whoa, this actually works. Using a service called Lambda, you can create Lambda functions that run a single execution of your code as many times as you need. To build an entire app this way is called serverless architecture, and it forces you to think about the organization of your application in a slightly different way. And although it's called serverless, it's actually taking your source code and building and running a container for you, which is running on an EC2 virtual machine on a physical server within an AWS availability zone. Serverless doesn't mean that there aren't servers involved. It just means that you don't have to deal with those servers. However, when you're debugging problems with your Lambda functions, it helps to understand a bit about the magic behind the curtain.
You can find Lambda in the AWS console by clicking on Services and typing in, yep, you got it, Lambda. I've got an example Lambda function here, and I'll just run it by clicking the test button. In serverless design, you don't want a large function, like maybe you could pull off with a Node.js container that does several things, but you want this Lambda function just to do a single thing. So if your app would have 3 larger containers on ECS, in Lambda you could break that down into maybe 15 functions that do the same thing. Here's another example function that we use in my other course on Simple Email Service, or SES. The Lambda editor takes inputs, like it can run this Lambda function every time a timer goes off, or every time Simple Notification Service, which is SNS, sends it a notification. So in this example, it's triggered every time an email message is bounced back to us. You can even set up Lambda functions as targets for application load balancer. So anytime someone goes to say halvanta.com/signup, a Lambda function will process that HTTP request and return the response to it. So you can build an entire web app using Lambda, or you can even expand your existing web app with new features that you just quickly code in Lambda. Search our catalog for Lambda for a closer look on what you can do with serverless architecture.
Remember our Lambda functions? These are great for code that runs quickly, but a single execution can't run any longer than 15 minutes. If you have a job that needs to crunch a bunch of data or wait on something to come back from a service or database, you'll need to look at the services that AWS has for batch processing and workflows. You can use the messaging services that we talked about earlier, like SQS, within your Lambda function. And that could be the trigger to kick off a batch processing job to, say, resize a bunch of images. Or it could be the start of a more complicated workflow where, say, an image is processed, someone manually reviews it sometime in the future, and it goes through another layer of processing and is reviewed again. In other applications, I've seen these jobs handled by either having a long-running process within the app somewhere, and that's not good for the server, or there's a cron job somewhere, and that runs in the middle of the night, and it crunches on a bunch of data. Now, if your app has some tasks like this, let's take a look at a few other ways that you can accomplish that same job in AWS.
If your app needs to crunch through some backend jobs, take a look at AWS Batch. It's a great way to manage and schedule jobs that can use EC2 Spot instances. Spot instances have a model very much like Priceline for airfare, where you can bid on using Amazon's unused capacity at a steep discount, but you can get bumped from the flight if someone else is willing to pay full price for your server. This is great for workloads that just have to be done sometime before next week or sometime before tomorrow morning, and you can save some serious money if you've got some flexibility on when your jobs get done. If you have a multi-step workflow that you need to manage, look at step functions. Step functions are great when you need to step through a series of tasks, and they're easier to read and organize than a 3,000-line bash script that you would have just run as a Linux cron job. If your workflows are super complex and you've got decision trees that spawn off into other workflows, look at AWS Simple Workflow, or SWF. But if you can run your workflow from a step function, always go that route and only pull out Simple Workflow when you really need a heavy hitter. We've got courses on all of this in the catalog, so if you can use any of this in your apps, watch a few of our videos and see if these services fit your use case.
We're now moving up to the Software as a Service products, abbreviated as SaaS. In this part of our AWS Starship, high above the engine room, this is the nicest part of the ship. The towels are folded for you, and your food is brought directly to your door. These are services you can bake straight into your application, and you don't have to worry about how it's hosted or how you're going to maintain it. These services just work, and in the shared responsibility model, most of the effort is now on AWS, and it's off of you. All of these services that AWS offers are built on top of the EC2 and storage options that we already looked at, but at this level, you won't see any of the servers running this software or have to manage them in any way. You just use the service. They bill you for what you use, and AWS worries about keeping it up and scaling it. One such set of services is the AWS tools for storing login details for your app's users. Managing password hashes in your database and making sure you're practicing proper security in case of a data breach has always been a struggle. But AWS has a few services to help you manage your user authentication for you. One of those services is Cognito, and it can help you implement sign-in integrations with other providers, so your users can sign in with Google or their Facebook logins. Let's take a look at how this works.
To see what Cognito can do for you, click on Manage User Pools. Click Create User Pool, and for pool name, just give it something like Cognito LN Demo. This is a pool of users where you would store all of the users related to your app. So you can call it Project X or whatever matches the name of your app. If you are hosting multiple applications out of this AWS account, you can create a pool for each application if you've got separate lists of users for each app. Click through some of the submenu options on the left and you'll get a sense about what Cognito does. You can select whether your users sign in with a username they select or an email address. You can select if they can verify their account using a text message sent to their phones. You can even wire this into Lambda, so a Lambda function triggers every time an event occurs in Cognito to customize some portion of the user experience. For developers, this is a huge sigh of relief because hand-building user authentication systems doesn't seem hard at first glance, but there's a ton of small pieces to consider, and Cognito just handles all of this for you. On the Review tab, scroll to the bottom and click Create Pool. Once the pool is created, you'll see additional options on the left for giving your users the option to sign in with their Facebook or Google accounts, although these integrations require some additional setup on your part to link your Cognito user pool with these third-party services. Search our catalog for Cognito, and you'll see examples of how to use Cognito in a sample mobile application. If you're building a mobile-only application, or you're building a web application that'll also have an associated mobile app that goes with it, AWS has a few things for you to check out. API Gateway lets you define a REST API and then route certain endpoints to targets that'll answer those endpoints. So halvanta.com/API/login could be handled by a Lambda function, but API/report could be answered by a fleet of EC2 servers that, say, generates reports for your customers. Or it could be answered by a container in an ECS cluster that handles all of your reporting. Application Load Balancer will do some of this routing as well, but if you want to define a fully featured REST API, I would look at API Gateway. If you were designing an application backend using GraphQL, take a look at AWS AppSync. Now, if you're new to GraphQL, we also have several courses in the catalog that'll introduce this new API to you and how you can use it in your apps. AWS also has an app framework for helping you set up some of these components using some easy-to-use CLI commands. The framework is called Amplify, and with a few simple commands, it can create a boilerplate React and React Native app for speeding up web and mobile application development. It can also help accelerate your native iOS or Android mobile applications by giving you a quick way to integrate user authentication, online file storage, push notifications, and analytics. Search our catalog for AWS Amplify and check it out if you want to try out Amplify for yourself.
We've been hearing a lot about machine learning and how computers are beating us at Jeopardy and how they're learning to drive cars. You may not be developing an app that plays trivia games or drives cars, but there are pieces to this technology that you can bring into your app to provide some enriching features. However, setting up these servers and learning how to use them can be overwhelming. So AWS has given you some tools that you can build directly into your app to leverage machine learning skills to help with image classification, reading text, understanding voice inputs, translating text into other languages, and several other sci-fi future technologies. Let's take a look at what they've got to offer.
Machine learning seems like stuff for smart people. And if you're into all things machine learning, AWS has SageMaker, which helps you build and train machine learning models without making you go through all the hassles of managing servers directly. If you're an aspiring data scientist, this is great news because you want to work with data, not learn how to manage a fleet of servers. We've got a great course on getting started with SageMaker, so just search the catalog for SageMaker. For the rest of us, Amazon has packaged up some machine learning technologies in an easy-to-use set of APIs that you can just bake directly into your app. You can pass a block of text into Comprehend, and it can tell you the mood of the writer. So this would be great for chatbots to find out, is a customer starting to get frustrated, and then maybe transfer them to a live agent. You can see a few use cases on the Comprehend page, and it'll show you some example text and then what response you'd get back from using Comprehend. You can use Lex to build a chatbot for your apps, or you can use Personalize to promote recommended products to a specific user based on their shopping habits. Polly can narrate dynamic text into some pretty lifelike voices.
Hello. Do you speak a foreign language? One language is never enough.
Rekognition can find faces in an image or extract text from an image, but if you're processing a large number of documents or handwritten forms, look at Textract, which can automate a lot of this for you. Translate can translate text into several languages, and it can even detect the language that you're passing into it. Transcribe will work like Alexa does and take natural speech and transcribe it to text. Hello, Amazon. Are you hearing me right now? You can use these services to build out some really cutting-edge features that otherwise would be pretty hard to pull off with a small team or a tight deadline. If your application uses live video streams, then check out a few of the products listed under the media services offerings of the AWS catalog. Now, I think some of these are edge cases for most users, so I'm not going to cover these in a lot of detail, but I do want you to look at Media Convert because I do believe you might have a need for this. In the AWS console, in the Services pull-down, type Media Convert. And then click the Getting Started button. If you work with a library of video content, then you can create workflows with Media Convert that'll take files from an input S3 bucket and convert them into various video formats and optimize them for web and mobile devices. But you can also do some neat stuff with this, like overlay a watermark and splice in bumpers. If you have a media team that takes your content and adds this stuff manually, you can speed up their workflow and do some of this automatically. You can also use this service to process user-uploaded videos from your mobile application, and since its output target is an S3 bucket, that bucket can then replicate across the world using CloudFront.
Alexa, turn the lights on. Smart devices are everywhere now, and the Internet of Things, it's here to stay. The application that you may be developing might be an app that controls a new set of smart plugs that your company is designing, or reads data from a fleet of telemetry sensors reporting on current weather conditions, or It collects data from trackers installed in a fleet of cars. If you need to build out your infrastructure to read and control these devices, let's take a look at some of the tools that AWS has created for helping you manage and develop apps for your fleet of devices.
For Internet of Things, or IoT, if you're entering this market space, then you either have the intention to build an app or service that includes smart devices, such as you're going to build out a killer web and mobile app that helps you track a fleet of vehicles, or you already have a hardware component designed, and now you're writing the software to help you manage this device out in the field. If you know the service that you want to build, but you don't have devices selected yet, check out the AWS Partner Device Catalog, because this will give you a good idea of what's possible with the AWS services for managing IoT devices. So, if you search for vehicle, you'll see an IoT device that plugs into your car's diagnostic port, but you'll also see a dash cam that you can integrate with. If you already have a device picked out, then you'll need to start collecting data from that device and controlling it while it's in the field. And some of these devices may use cellular connections that are unreliable, or the device may simply be off when you try to send commands to it. So it gets really difficult when designing your own software to manage the state of all the devices in the field. Just because you sent a command from the server to tell the light to turn on doesn't mean it really turned on. AWS IoT Core gives you a set of services that helps you manage a lot of devices. If you're developing software and firmware to run on the device that you're designing, they've got software such as FreeRTOS that helps you communicate with IoT Core and get your telemetry data up to Amazon and your commands to and from your device. If you're building an application that uses IoT devices, spend a little time with the AWS services and see if these fit into your use case. You can build software to manage IoT devices by hand, but why would you want to do that if AWS has done a lot of this work for you?
Man, this new feature is going to be great. Hey, here's that new code release. I need that up by 6 tonight, okay, buddy? Thanks. At the start of my career, I was this developer, and I couldn't understand why IT couldn't just push a button and release my code. I had deadlines, and customers were waiting on my bug fixes. And then, ironically, later in my career, I became the IT person who took the buggy code from the developers. Now I was responsible for keeping the servers fast and stable, which put my new priorities at odds with the developers who always wanted to change stuff. DevOps removes the barrier between these two teams and creates a single team that has responsibility over development and operations, DevOps. The developers now help maintain the servers, and the IT people now start working more in the code. Now the DevOps team has shared goals. They need to release new features and maintain site reliability. And instead of just asking the question, is our site up? A DevOps team asks the question, is the site running well? Which is a much different approach that now includes things like backend API response times. If new code is released to the site that causes a drop in site performance, a DevOps team should be able to trace that dip in performance back to the code that caused it. And with cloud technologies, servers aren't these prized possessions anymore that take weeks to set up and configure. We used to give servers clever names, such as choosing a name for them from the list of moons in our solar system. Now they're just easy come, easy go. We can start looking at infrastructure like we look at code, as throwaway objects derived by defined classes. If something's not working, we just delete it. If I need 100 servers, I'll just define it once and then loop over my code 100 times. Let's dive into the services that AWS has created to help us on this journey to a DevOps team. Every time I make a change to my code, I need to check in the changes into my source control, rebuild my app, and then package it back up and deploy it to my platform or my EC2 servers. But what if every time I checked in my code, all this just happened automatically? Imagine how much faster you would be and the team would be if every time a code change is approved, it's automatically tested and deployed to a staging environment, and then, if everything's working, deployed into production with a single click. A key component of agile development is to release early and often, and this allows the development team to make smaller changes to the code more frequently. And combined with automated testing, performance monitoring, and feedback from your users, it allows you to find bugs faster and to easily identify which small set of code changes correlated to the introduction of that bug. To align with this agile principle, a key DevOps practice is the creation of a system that allows for continuous integration, or CI, which allows the code changes from multiple developers to play together regularly to work out any conflicts when two developers are both working on the same file. It can also run an automated test suite against the code to make sure that the new changes haven't broken anything. For that, Amazon has a tool that's called Code Pipeline. Code Pipeline can be used to create a workflow that automatically pulls your code, such as your code that you have in GitHub or code commit, and then builds your project and run some automated tests using code build. A related key DevOps practice is called continuous deployment, or CD. And this step would occur at the end of your pipeline so that you can quickly introduce these changes into your production system without manually moving new code and changes up to your fleet of servers by hand. Code Pipeline can use code deploy and continuously deploy your tested code from your container platform, like ECS, or directly to your EC2 servers. Now, if you want to see a full code pipeline in action, check out my other course on ECS and multi-region load balancing, and I'll walk you through setting up an example container that automatically deploys to ECS whenever you make a change to it and check it into code commit. A key component to DevOps is treating your infrastructure as code. Earlier in this course, we looked at physical server racks and servers, and while all these objects exist in the real world, in the cloud, these are just representations of virtual components that we've wired together. And because all of this is virtual, we can start treating our infrastructure as bits of code. Using code to describe your infrastructure allows you to keep a single source of truth for the configuration of your servers. It's like a packing manifest of everything that should be on that server and describes and documents the server in a very real way. Okay, for example, if you have 10 identical web servers behind a load balancer, and let's say a change is made manually to a single server, the problem will only show up for your users 1 out of every 10 times. And so it's hard to figure out which server is different. Deployment automation tools can check all of your servers against the source of truth and set configurations back to their original states. The 3 most popular open source tools for this are Puppet, Chef, and Ansible. If you're already using Chef or Puppet, AWS has a service to help you set up the control servers for these tools, and that's called AWS OpsWorks. Okay. In addition to Puppet, Chef, and Ansible, AWS has created their own infrastructure management tool, and that's called CloudFormation. Whereas Ansible and Chef really shine with the management and configuration state of several servers, CloudFormation goes a level deeper for AWS customers. It allows you to script the creation of EC2 servers, VPCs, load balancers, and almost any of the AWS infrastructure and platform services that we've looked at so far. We've got several resources in our catalog on CloudFormation if you want to get started with describing your AWS resources as blocks of code. My advice with CloudFormation is to start early on with it and build it up over time. It can be difficult to wedge an existing AWS infrastructure into a new CloudFormation template that completely describes and configures it. So it's a lot easier to start with CloudFormation from day one, and as your app grows, grow your CloudFormation templates.
One change that DevOps made on how a service operates is to expand the role of monitoring the service past "is the site up" to "how is the site actually performing?" The easiest way to think about this is to look at the status page of a popular SMS messaging service called Twilio. Now, their status page is showing a high-level status of the various parts of their service in a stoplight format. Red, it's down; yellow, it's having problems; green, it's up. But if you scroll down to the bottom of this page, you'll see that they have a line graph of their API's performance over time. The old way of thinking simply thought of the entire app as red or green, stop or go, is it up or down? But with a DevOps mindset, if you introduce a code change that doesn't take down the service, but say it negatively impacts response times and now the service is running slower, your DevOps team should spring into action and trace the root cause of the slowdown and work to restore the response times to normal levels. In the CloudWatch console, you can click on Metrics on the left-hand side, and then click on under All Metrics. You can select the EC2 card, and then select Per Instance Metrics, and you can see a lot of the metrics that CloudWatch is already collecting on my running EC2 instances. For Linux machines, you can install a CloudWatch agent into the virtual machine that will report more metrics to CloudWatch, such as memory usage, which you won't see in the previous list. You can also use CloudWatch to log errors within your applications, so you can spot problems this way as well. CloudWatch ties into several AWS services, and you can do a lot with this to monitor your cloud infrastructure, but its strong suit has never been getting underneath your code and spotting slowdowns. This area is called Application Performance Monitoring, or APM, and there's some third-party companies that are AWS partners, such as New Relic and Datadog, that have some expensive services that tie into your code and do a little bit more. If you're even remotely interested in these services, their sales teams would love to talk to you about it. Search our catalog for AWS DevOps to dive into CloudWatch a bit more, but in practice, I've usually used CloudWatch to place monitors on certain key parts of my cloud infrastructure, such as EC2 status checks and ECS container counts, and then feed that data into an external monitoring tool that reads from CloudWatch. Your needs and budget are going to be different, but CloudWatch is more like wearing a heart rate monitor than going and getting a full checkup from your doctor, so keep that in mind when you're planning out your monitoring solution. Now we're looking at the shields surrounding our AWS Starship, and their primary purpose is to deflect attacks from hackers. There's a lot of security features to AWS, and we've already looked at a few of the things that we can do, such as security groups and some of the features of IAM, and there's a lot more we could have dived into with this. AWS has a very short guide on some best practices on security, and we've already implemented some of these earlier in the course, and now we'll talk about some of these other items later in this chapter. It's a very short read, so I recommend looking through this because I'm not going to be able to cover every bullet point here. But I do want you to be aware of two AWS services that help with filtering and blocking suspicious web traffic: WAF, or Web Application Firewall, and Shield. Web Application Firewall can connect to your load balancer, and it can be used like any other firewall product you might have used to filter your web traffic. So your service only responds to customers who are, for instance, within the countries that you operate in, and blocks IP traffic from countries where you don't offer service. This will mitigate some attacks, but one really powerful feature is that they have managed rules that you can subscribe to. So if you're running a web application, there's a set of managed rules that are being updated constantly to combat the latest threats. And this can really help out if you've got 100 other things you need to be doing and you don't always have time to keep a close eye on the web server logs for that, one WordPress marketing site that you're running. Another product to take a look at is Shield, which can help mitigate a denial of service attack against your application. AWS does have security experts who are monitoring the network as a whole and trying to mitigate these attacks, but a denial of service attack against your specific application will fall into your side of the shared responsibility model. If you have an application that's at high risk of being targeted by bad actors controlling botnets, look into Shield Advanced to get some extra help from AWS to protect your app against these denial of service attacks.
I mentioned previously that for your WordPress marketing site that runs off that single EC2 instance buried in your account somewhere, you may not always have the time to dig through Apache server logs and look for hacking attempts or signs of intrusion. Using the managed rules for WAF will block some of this stuff from getting into your instance, but an unpatched WordPress plugin could be an easily exploitable door for even an entry-level hacker. Because you can't always keep an eye on everything your server is doing, AWS created GuardDuty. Think of it as the night security guard walking around your server, shining a flashlight into closets and folders of logs that you may not always be looking at. GuardDuty can find suspicious network connections that your server might be making to indicate that it's been compromised. It's an extra set of eyes on how your server is behaving to see if it's doing anything that looks out of place. Now, getting started with this level of security can be overwhelming from a developer's perspective, especially if you've never had to deal with servers or infrastructure before. Inspector is like a full scan of your cloud infrastructure, and it looks for unpatched servers or common security vulnerabilities that you'll need to fix or block access to using your firewall. If you stepped into an AWS account that was managed by somebody else and you are now responsible for the security of your application, this is a great place to start. And as you make changes to your application and cloud infrastructure, you can rerun this scan periodically so you don't miss anything. Think of it as a full virus scan for your AWS account, looking for potential security problems. And do you remember how many times I mentioned in this course to not put sensitive data in a public S3 bucket? AWS made you click through several settings and warnings to prevent even sharing a single file from an S3 bucket, and I made you read all of those warnings. Because this has been such a problem, AWS has a service called Macie that'll scan your cloud resources and look for things that look like sensitive data and report it to you if you're publicly sharing this information. Now, if all the companies on the S3 Wall of Shame had just used Macie, then we wouldn't be reading in the news about how much data was easily collected from a data breach. If you handle sensitive data for your application, then I recommend looking at Macie to help keep this data secure. Even if you know what you're doing with an AWS account, sometimes things like this just happen because you didn't have time to perform an audit of your S3 bucket and its settings, especially, when you've got 5 other projects due. Ask for the budget to run these services on a regular schedule because it's much cheaper than a data breach. Sometimes problems with hacking and data breaches don't always originate outside the shields to your AWS Starship. You've got a good crew, but that green guy you picked up at the last Starbase has been seen poking around areas of the ship you aren't sure he should be in. CloudTrail is an audit trail of changes made internally to your AWS Starship. It can also log requests coming in through the AWS API and let you know if somebody's made off with your AWS access keys and is using them for the wrong purposes. Not to sound too paranoid here, but these are always things that happen when we aren't looking and when you least suspect them. CloudTrail can be used to trace back in time what someone was doing in your AWS account and what changes were made. Now, I hope you never have to use this, but for applications that store and manage highly sensitive data that's regulated by compliance standards, it's probably wise to look into CloudTrail so that you can spot problems before someone tries to delete all your servers. And I know I've thrown a lot of different security products at you, but Security Hub tries to bring a lot of these products under one dashboard. Think of Security Hub like the security workstation on your ship's bridge. It's like a single readout of things you should look into from these various security products. So if you think this service would be valuable to you, I highly recommend that you search our catalog for Security Hub to see it in action.
The first thing to do is clean up. Make sure you terminate any EC2 instances that you started and release any Elastic IPs. Delete your application load balancer and delete any EBS volumes to the instances that you spun up. Also, make sure you delete your S3 buckets and any CloudFront distributions that you don't want. If you clicked around and explored on your own, check your bill at the end of the month, and even if you don't get charged this month, check the line items because they may fall under the free tier, and in a year, you might start getting billed for those services. Because AWS has so many services and they're releasing new ones all the time, use the AWS website and just roll over the Products tab, and then just roll over the various categories and read the product names and the short little description that they've given to each service. Now, I've run several large and small production workloads in AWS for years now, and I know generally about what 90% of this does. I've used probably more than half of the services, and I hesitate to even call myself an expert in even about 25% of it. So please don't feel discouraged if you look at this and you think, I'll never be able to learn all of this. Just look at the services you know you'll need for your app and then search our catalog to learn more about them. Some free resources to keep you up to date with AWS are the AWS blog. Just click on this link so that you can read the latest product launches that are usually written by Jeff Barr. Also, check out the AWS Online Tech Talks. These are great webinars that you can sign up for, and even if you miss the live webinar, they'll usually send you a link later to their YouTube channel so you can watch it later. Also, look at the AWS This Is My Architecture video series, which will interview other developers and have them walk you through how they used AWS services to build their app. You can also attend an event in your local area or go to one of the larger conferences and do some panels. Check out the AWS events page if you'd like to go to an event. And if you just want to improve your general knowledge of AWS, start on the certification track, but a certification isn't a replacement for hands-on learning. If you're pursuing the certifications to get a job doing more AWS work, I would highly encourage you as a developer to build your own app on the side and use what you're learning on the certification track to support your app. Listen, certs are great, but showing employers that you can actually do something with AWS and host and scale a real app is much more impressive. And if your app takes off, be sure you float some shares my way. Thanks for spending this time with me, and I wish you good luck, safe travels, and warp speed ahead.